Good afternoon, everyone, on this Sunday afternoon for the third day of the Color Society Seminar Webinar 2020. And it's great to see all these attendees joining. It's nothing but their, I think, love and affection for Color Society that they are spending their Sunday afternoon with us. So we have a series of technical sessions today, including one of the sessions which could not be done yesterday by Mr. Surendra Gupta. So we have 5 technical sessions today, which will be followed by a panel discussion. So please do stay tuned for that. So for the first presentation, I would like to invite Mr. Jaivan Patil, who's from Kansai Nerolac Paints Limited. Mr. Jaivan Patil is a BSc Tech from University Department of Chemical Technology, Matunga, Mumbai. Currently working as Senior Manager in Technology Department at Messrs. Kansai Nerolac Paints Limited. Job profile being development of various polymers used in paints comprising of alkyds, polyesters, acrylics, amino for automotive, industrial, and solvent-based decorative applications. In addition to, he also plays a role in development of various systems for wood coatings and focus also on being UV coating. He has a rich experience of 25 years in research and development, including assignment of international exposure. So with this, for the first session, I'd like to invite Mr. Jaivan Patil for his technical talk.
Yeah.
Jaivanji, you can share your screen. Hello.
Is it visible?
Thank you.
Yes, Jaivan, it is visible. You can start.
Good afternoon, everyone. My name is Jaivan Patil. Today I am going to talk UV curable as a emerging trend in industrial applications. First, I will thank to society to give me opportunity to connect with you all respective dignitaries and pioneers of coating industry through this webinar. Today I am going to present on UV curable coating, but before that, I will give the current scenario of Indian market. In Indian market, if you see, mainly Indian automotive market is dominated by air drying systems and stowing finishes. But it has not reached to that level in UV curing systems. If you compare against globe, it is not much penetrated. But yes, if you take ink and optical fiber, then in some extent it has reached. Now, if you see this market, there are so many initiatives. Customers are asking, like, can you reduce my stowing temperature? Can you improve my productivity? And this can be achieved by UV curing techniques. So let us discuss on UV curing coatings. If you want to discuss on UV curing coating, first you have to see electromagnetic spectrum, where the optical area is there. In that optical area, ultraviolet radiation, visible lights, and infrared radiations are there, where that is from 100 nanometers to 1 lakh nanometers. And again, ultraviolet radiation subdivided into different types of UV rays, that is UVA, B, C, and V, and that is from 100 nm to 400 nm. So, as our topic of discussion is UV coating, we have to more focus on ultraviolet radiation. So, this is more important for us today. Now, to get just initial idea, what is different between solvent-based conventional system and UV cural system? If you see solvent-based system, as you all know, it contains solvent, polymer, additive, and pigments. In case of UV curable coatings, oligomer and monomers are there, and one more thing, that is photoinitiators are there, and which can trigger the reaction and initiate the polymerization reaction. Now, as a developer, formulator, we have to understood what is difference between drying and curing. If you see, in case of drying, solvent evaporation and there is no or less cross-linking will be happen. But in case of curing, there is a chemical polymerization, cross-linking will be happens. Now again we'll see in next slide, again what is different between these two curing techniques. That is curing with UV curing and that is and thermal curing. If you see thermal curing, curing is initiated by heat. Heating, cross-linking reaction will start and polymerization will take place. Again, that depends on different polymer chemistry. Suppose that is PU, then you have to heat up to 80. Suppose that is alkyd amino or acrylic amino, then we have to heat up to 130, 140. Depends on final requirement. But in case of UV, curing, if you see this UV light, this will trigger the reaction and polymerization take place instantly. So this is the main difference between these curing techniques. Now, as our topic is UV, so how these UV rays are differentiated and that these three UV rays are important for UV curing techniques. If we see, higher the wavelength, then penetration is more. And if the lower the wavelength, then penetration is less. So as per requirement, if you see UVA is from 320 to 400 nanometer, and that is penetration is more, means depends on that nanometer, penetration is more. Now we'll discuss on formulation part. In formulation part, you see oligomers are the main ingredients used in UV curing techniques and which governs the main properties like hardness, toughness, fragility, all performance properly mainly governed by oligomers. These are the oligomers: epoxy acrylates, urethane acrylates, polyester acrylates, amino acrylates, and acrylated acrylates. Then second most important part is a monomer. We called it as a reactive diluent. It is main uses to adjust viscosity. And again, in monomer there are monofunctional, difunctional, trifunctional. This type of monomers are there. And this we can use as per requirement of property of final film. Then photoinitiators. These absorb light and create free radicals and start polymerization reaction. These are mainly two types: phenylketones surface curing and benzoquinone, that is throughout curing. And additives are there, which we can use for final tuning of the coating. Now we will discuss detail on oligomer. In oligomer, if you take epoxy acrylate, this gives very fast cure, good chemical and photo resistance, and it will give high gloss, but it is with low cost. But if you see, epoxy is having chalking and yellowing problem when it is used for exterior purpose. So as per your requirement, you can select the epoxy acrylate or some which acrylates you can take in extra quantity. So second one is urethane acrylate. Again here mainly two types are there: aromatics, which is of low cost, and then aliphatic, that is non-oiling, which is expensive, but it will provide toughness with flexibility. So very tough film you can get with urethane acrylates. But again you have to formulate as per requirement because its cost is higher when you use aliphatic. Then polyester acrylates. This is mainly used for wetting and flexibility. Then acrylated acrylates. It gives good hardness and adhesion on difficult surface. The second most part is important is monomers. If you take monomers, monomers are reactive diluents. So this we can use for reduce viscosity of the UV curable coatings. If you take monofunctional monomers, then it reduces viscosity. It will be low reactive. For example, IBOA, that is isobornyl acrylate. Then second one is difunctional monomer, that is low viscosity. Again, it is a medium reactive. And for example, HDDA, 1,6-hexane diacrylates. And third one is trifunctional monomers. Here reactivity is increased and viscosity is also increased. And this is a TMPTA, that is trimethylpropane triacrylates, and multifunctional monomers. It is high reactive and it will give very hard film, which can be brittle also. So example is di-TMPTA. From this slide, you will come to know how monomer properties or monomer functionality will affect the final film properties of the coating. If you increase functional monomers, then flexibility and adhesion will be increased. However, reactivity, solvent resistance, and tensile tense will be decreased. Then we have to use, for that we have to use di, tri, or tetra functional monomers, which can increase your reactivity and solvent resistance. So accordingly, you can formulate your coating as per your requirement. Then here, polymerization is triggered by UV light, and if radiation light falls on the coating, which trigger the reaction, that is, first this radiation absorb light, UV light, then it generate free radical, and then the initiate the polymerization, that we will see next slide. You see here, initiation, propagation, here radical form is there, propagation and termination reactions are there. In presence of UV lamp, photoinitiator initiate the reaction and initiate polymerization reaction. It's just like a free radical acrylic polymerizations. Now we'll go to UV equipments. UV equipments main part is UV lamp. that we can select based on your requirement. That is mercury lamp mainly used. And reflectors are used for collective energy to reach that energy to inaccessible area. And shutters are there. Shutters, with help of shutters, energy level reach to confined UV chamber. And there is a cooling system is there where the cold air are blown. So this is actual EV equipment, how it looks. This is reflectors. It reflects the UV light. And collectively, it will be reached to the inaccessible area. Then UV lamp, mainly mercury lamp, discharge lamp is used. This is our low pressure lamp, amalgam lamp, and medium pressure lamp. Mercury lamp has its should give right intensity, and mercury lamp itself has its shelf life. It's occasionally you have to check its shelf life. Some days its strength will be decreases. So accordingly, you can change the lamps. This is the diagram how the mercury discharge lamp looks. It contains the accessories as shown on slides. It's a comparison between LED and mercury based lamp. If you see, both are having advantages and disadvantages. If you see mercury lamps, it gives higher energy resulting in faster cure, but it radiates high radiations, and it gives broadband emission. But in case of LED, it is having low energy and it is monochromatic. This is the actual UV machine used for UV coating at the production side. From here, article to be passed from here, it will go through UV chamber and it will pass out from here. So here curing happens and it will pass through, and it will be curing will be instant curing. So your main thing to control is the line speed. If you see curing performance, other than formulation, curing performance depends on source of UV light or energy and line speed. If line speed is low, then your article will be more exposed to UV light and it will give hard and brittle film. So again, it will be not useful. If line speed is very fast, then sufficiently UV light will be not exposed, and that article will have very low hardness or adhesion. So source of energy checked by UV power instrument. Now we'll go to next slide. Application process, if you see, mainly roller and spray coatings are mainly used for UV coating, but spraying is the main used for applications. This slide is intention of giving this slide to get some basic idea for UV curing, because for UV curing, plastic is the main substrate which can use for coating. So before that, you should get all idea regarding the how that polarity is there, how surface tension of plastic is there. So that's why this slide is given. Now we will move to application process. There are different types of application process. Suppose substrate is a ABS type. So if we take ABS, then ABS is having good adhesion to plastic. UV coating is having good adhesion to ABS. So you can directly clean this ABS or this coating with IPA. Then we can spray this with UV clear coating, and then it is preheated and it will pass through UV chamber. In preheating, whatever amount of very few solvents are there, that will be removed for that preheating is there. In second, again one more process is there. Here, suppose your substrate is having less adhesion to UV, then it has to be coated with base coat, which is based on 2 kPu acrylic base coat, and then UV clear coat can be applied. Then same procedure like clear coat, that is preheating and UV curing process is there. Here, in case of polycarbonate, adhesion of UV is very poor, so here this base coat is required. The effect of lamp, power of curing. If you see, if low lamp is there, UV lamp is there, then curing is not proper. If high lamp is there, then extra curing, give brittle film. Correct UV is there, then you will get proper curing and you will get desired film properties. Now, effect of coating thickness on curing. Thickness is very important in UV curing because you have to cure this film with help of UV light. Suppose too thick film is there, then only some part will be full cured, some part will be under cured, and some part will be uncured. Suppose you reduce thickness, then again improvement will be there, but again some part will be under cured. But suppose you full cured, suppose thickness is proper, then you will get full curing and you will get desired property including adhesion and hardness and flexibility. This is just how this UV curing techniques can be used for different applications. UPC market views. There are two types of markets, that is enabling market and conversion markets. These are the enabling markets and these are converting market. These articles can be coated with clear UV clear coat. Again this is same. Suppose you require high scratch resistance, for example for helmet, we can use this UV curing techniques. Now safety. For safety, it is more important to handle safely, just like our normal chemicals. Use protective gloves, thin dental gloves, do not use latex gloves. Adequate gloves to be used while cleaning, especially with solvent. Wash hands soap and water after contact with UV. Then eyes. During uses of this UV machine, you have to use safety glasses all time. Never look directly to UV sources, even with your protection also. And avoid wearing contact lens during its uses. And this is just like our normal practice. Eating and drinking, smoking is prohibited in the immediate area where these products are being handled.
Jaivan, you have 5 minutes more.
Okay. Only 2 slides are there. All UV
Okay.
curable reactive, hence store at very close container between 10 to 25 degrees Celsius, because it having monomers, oligomers and photoinitiators, and avoid excessive heating. Constraints are, this is a novel technology, adhesion problem on some substrate. It is higher initial investment of machines, and odor is typically different as it's having monomers, oligomers. Benefits are more rapid, high productivity, immediate drying, high gloss and scratch and solvent resistance. Then ease of machine start is good, and machine space is less required for this. I will have conclusion. UV coating would be a new approach for fulfillment of unmet performance. Thank you.
Jaivan, thank you very much for your excellent presentation, and topic was also very nice, because globally everyone is focusing now on the how to reduce the VOC. So nice presentation, content was also nice. So Jaivan, you have some few questions.
Yeah.
First is, this is based on this UV curing coating is based on monomer, oligomers and polymers.
Yeah.
So say when we apply this on any substrate, so
Yeah.
due to it contains the monomers, so is this coating will give the some smell, see, when we apply on any substrate?
No. It will not
So
give
it will
any. Yeah.
Okay. And secondly, this UV coating, it contains the photoinitiators.
Yeah.
So how is the shelf life?
Potential, if you keep properly, or if you keep it at proper less than 25 degrees Celsius in closed container and do not expose to sunlight, then it will be shelf life will be 6 months to 1 year. But
Okay,
again,
so
it should not be exposed to direct sunlight, because photoinitiators are there. And do not metal containers.
Okay, since this can be used for this plastic applications. So
Yeah.
do you have tried for some other application like paper or some other application, heat sensitive applications?
No, we have not tried, because requirement is not there, so we have not tried. When requirements come, we can try it.
Okay, fine. And one more question. So this coating, this is commercially available, or it is on the trial basis or pilot scale?
What? Just pardon?
So this UV coating, this is commercialized, or this is under development or pilot scale?
No, it is commercialized, already commercialized. We are supplying to 2-3 customers.
Oh, that's great. Aditya, do you have?
Yeah, there are some questions.
Audience?
Yes. We have 5 minutes. We can take some questions.
Yeah.
Okay.
Yeah. So there's one question from Sanket Shinde from Bosco Pigments. The question first is he's congratulating for a good presentation, and he has a doubt basically on what type of accelerator we can use to accelerate the reaction, and also there is chances of gelling since we are using high functional monomer. Then what precautions do we need to take?
Now, whatever we are discussed here, now we are discussed on clear UV coatings. Pigmented UV coating we are not discussed, because pigmented UV coating, if you see, each and every pigments have different absorption. So each and every time you have to change the UV energy. So many complications are there. So initially we are focusing on only clear coatings.
Okay. So there's a question from Dr. Tipanna who's asking usually what is the thickness of UV coating for getting fully cured?
Thickness is very less, around 20 to 25 micron like that. So you will get within this low thickness, you will get good properties.
Okay. And Mr. Shrikant Joshi is asking, are the raw materials available in India for manufacturing UV coatings?
Yeah, available.
Moving on, I think there's another question on the UV source. I think Sachin Koer is asking, how do you select a UV source, A, B, or C?
No, that will be, if you see now that machine is there, I have already explained that UV power pack machine is there. Okay. Suppose you first you have to check with your mercury lamp. You have to check how much energy you are getting. Suppose you are getting less energy, then you have to again you have to take you have to start second UV lamp, because the lamp two to three lamps are there. As per your requirement, you can start, but you have to measure that energy with power pack machine. That separate machine is there to measure UVA, UVB, UVC. You will get directly readings.
Okay. So there's another question from Professor VC Malche, and he asks, blacks absorb all light and UV. Do you have formulation with black pigments?
No. On pigmented, we are not concentrated. Only presently we are concentrated on only these clear coatings, because black will have more energy, and we are not started yet on pigmented part.
Okay. There's another question from Vinayak Ashok Pawar, who's saying, can anything be done in UV paints which can add to give more corrosive properties, anti-corrosive perhaps what he means, but anti-corrosive properties?
No, that is different technology. Na? Paint is, because here we are already I discussed, this is only clear I am discussed. Paint is something different, and that is something complicated.
Okay. And there's another question, but again related to pigments, but what Dr. TK Roy is trying to ask is, how do you select pigment for UV coatings? I think it's clear that you are currently speaking about clear, but do you want to answer this? How to select pigments for UV coatings or not?
No. We don't have that experience also.
So other some questions are on pigment. I will skip them, but I will send it to you, send to the committee later, so they can forward it to you.
Okay, no problem.
Okay. So another question from Mr. Milind Mahajan, who's asking, what's the compromise in functional properties when compared with conventional 2 to 3 pack iodine stoving counterparts if you are using UV?
UV, mainly some skill is required, and you have to use proper protective equipments, and you should have initial that machine is main part you require for that. For normal spraying or conventional spraying, you can take spray gun, you can apply, you can store, finish. But for UV, main is UV machine is required, and that is expensive. That is the main thing. And here you will get sudden curing process with good hardness, and you can increase productivity in case of UV at lower temperature. So there is no oven required for storing.
Okay. There's one more question from Mr. Girish Tilak, who's asking, are there any advantages of hybrid technology? For example, high solids UV coatings.
No, UV coating is already high solid, na?
Okay.
Aditya, can I have one question?
We are not using any solvent. We are using reactive diluent, that is monomer as a solvent. So there is no solvent.
Okay. Who's asking? Who said, can I have one question?
Aditya, I am Harish Agarwal. Yes.
Yeah.
Can I ask one question?
Yeah, sure.
Yeah,
Dr. Patil, there is a, you said UV curable coating, they are applied only on plastic. The MDF particle board, can this UV coating can be applied? UV coating, MDF particle board.
MDF particle board you can apply, but you require proper primer, sealer, on coat is required, because directly adhesion it will not give direct adhesion. So it required proper sealer, UV curable
Okay.
sealer, primer, and then you can apply.
No,
Directly as
basically,
like ABS you cannot apply.
basically, I've seen there is a system. First, the MDF particle board goes in the water tank, and primer is applied water base, on that top coat water base, and finally the UV curable coating is done. Is it possible?
No,
No,
no, no. On water base it will not work.
it will not work.
Yeah, not work.
Okay.
Because adhesion between UV and water base will be good, but adhesion between your substrate, that MDF and your water base will not good. So it will peel off, remove from bottom.
No, but I have already seen this in an Action Tessa. They are making
Yeah.
floor tiles, and I've seen this process. It is a water-based system, primer and top coat, and then on that they are applying solvent-based UV coating. I've seen this.
That may be special, maybe water base, maybe special or something may be there.
Okay, fine. Thank you.
Mr. Patel, one last question before we move on to the next technical session. This is from Mr. K. Raghuraman. He's also one of the panelists and Color Society member. How do you control thickness on application?
Thickness will be controlled by your spray gun pressure mainly, and viscosity of UV. Suppose you require very thin coat, then you have to use more monomer with controlled properties.
Yes.
And if you require high viscosity, then you can reduce your reactive diluents, that is monomers.
Okay. I think thank you, Mr. Jaivan Patil and Shivaji ji for being the member from the Solar Society for this session. So with this, we'd like to move on to the next presentation, which will be by Dr. Subhash Srivastava from KTech India. Dr.
Yeah,
Srivastava.
thank you.
Hello.
Thank you, Jaivan.
Thank you, Shivaji.
So I'd like to invite Dr. Subhash Srivastava, who's he graduated in chemistry from Kanpur University and obtained technology degree in chemical technology specialization in paints and pigments from HBTI Kanpur in 1979. Later post-graduation in various in management science in 85 and doctoral in financial management from Mumbai University in 2010. He started his career in ICI Limited, went to Ports of India and gained experience on the printing ink industry. And after gaining hands-on experience in paints and printing inks, he further enriched his experience in pigments with then leading multinational Color Chem, a joint venture of Hoist AG and Bayer AG from Germany. He spent 20 years in polymers, paints, printing inks, pigments, and varnish before embarking a new career in research, manufacturing, and marketing of specialty additives for paints and coatings, printing inks, pigments, polymers, and allied industries. He is the chairman and managing director of KTech India Limited, a specialty chemical and additives company engaged in research, manufacturing, and marketing of specialty chemicals for paints and coatings, printing inks, pigments, polymers, textile, leather, paper, and oil feeds. He is also very active in the CSR, corporate social responsibility activities, where he runs a charitable trust in the name of his parents, Srimati Kokila Mahesh Charitable Trust Foundation, which is engaged in education, old age home, and orphanage for the welfare of the weaker section of society. He also manages a primary and secondary education trust in the name of Bharatiya Shikshan Samiti, which imparts education to almost 3,000 underprivileged children in Thane, Maharashtra, India. With this, I'd like to invite Dr. Shubha Srivasta from KTech India Limited for the technical session.
Yeah. Are you able to hear me?
Yes,
Able,
yes, we can.
Yes,
Okay.
yes.
Before I embrace this subject, I must embrace and invoke Ma Saraswati, Goddess Sharda, because without her blessings, no technical enlightenment or knowledgeable talk is possible. So, friends at Color Society office bearers, presidents, general secretary, vice presidents, other members, my fraternity people in the audience, illustrious alumni, my seniors, my co-workers, my juniors, and beloved students, and also the business community. Indeed, it is a matter of great pride, privilege, and honor for me to be amidst a galaxy of people like you, the technologists, the chemists, the scientists, the business community. But before I proceed to my subject, high performance pigments, there are few things as a token of respect to Color Society and the institutions is necessary. Otherwise, it would be rude on my part. Color Society has been very close to my heart. My reverence and love and affection started in early 80s. As a graduate of paint technology, I came from another institute, another legendary institute, SBTI Kanpur. But ICT accepted me as one of it. And the Color Society, thanks to Mr. C.J. Bhumkar, my mentor, and whose emotional insistence and invitation brought me to Color Society. And I think in 1993, 94, I worked as a member and also the association bearer with Dr. K.K. Saxena for improving the membership from 300 to almost 800. It has been a great pleasure in associating with Color Society, and so is with ICT. I consider, I come from HBTI, and ICT and HBTI, those two are the twin daughters of, Ma Sharda, Ma Saraswati. And there have been absolutely no divide, because we from ICT and from Harcourtians, we carry the same mitochondrial DNA lineage, and we have gone together in several years. Dr. N.R. Kamath, Teji Kudwa, all were very respected, personalities at HBTI Kanpur. And so is our people like Dr. Malshe and other people who have also taught at UDCT and has been an illustrious alumni of HBTI Kanpur. As the president of Paint and Coating Technology Association, I wish my all good wishes to the Color Society. And we are alumni, and it's like Mausere brother, because by the relation we are Mausi ke ladke. So there is a saying, in northern India, there's a chor chor Mausere bhai. Whenever you see two professionals, the same in hand in glove, you will say chor chor Mausere bhai, meaning there is no division of property between the maternal aunts, the brothers. So we have absolutely no such things. And that's why, we gave Dr. Bhumkar, the fellow of, and also the Pinnacle Award. And it was so sweetly, as a sweet gift, returned to me in 2014 when the Color Society gave me the fellowship. And it has been a sweet romance, I would say. So now coming back to the subject, when the Color Society talked to me, and then they said something is post-COVID has to be talked about. And I have always been talking, writing on pigments and colors for Color Society. For printing people, I don't write printing things, and for paint people, I write paint things and talk paint things. But with Color Society is always my prerogative to talk on colors, the pigments, and the other things. That has been by default or by design has been like that. So I decided to speak on high performance pigments, a line which actually I left a pigment line 25 years ago when I started K-Tech, leaving Color Cave, when the writing on the wall was there that India would be not in the line of thinking of West and Europe, and it was Chinese centric. It became Chinese centric in 90s almost, where Hex, Bayer, Siba, BS, everybody exited, and they decided to put in Tianjin, you know, the huge plant of the pigments. And since then, of course, the color chem had to die a natural death, and I had to come out only thinking my career is finished with the pigment. But again and again, I left pigment, but somehow, as the luck would have it, I have been always, you know, lured back to the pigments. So again, I am talking high performance pigments to you with an understanding that in India, there are very dearth of, you know, high performance pigments. In COVID, post COVID-19, people will always have, you know, imports of only two things: high performance pigments and high performance additives. Additives are, I'm not going to speak because that is going to be otherwise a sales talk and a commercial talk, which I don't want to do and never done it. But high performance pigment is the one which India must go. And for that, you see, the global colorant industry estimate to 2020, which comprises of dyes, inorganic pigments, organic pigments. Dyes means acid dye, basic dye, sulfur dye, VAT dye, you know, reactive dyes, and vinyl sulfone dyes and whatnot. And the high performance pigment and special effect pigments and functional pigments all put together a colorant. These are about 11.4 million tons, 114 lakhs, those who are interested in knowing in lakhs. And also about $29 billion is about 2 lakh crore. This is the total global colorant industry estimate 2020. And out of that, we are talking about this industrial classification of our size, that is for paint industry, ink industry, plastic industry, the inorganic pigments, the organic pigments, the high performance inorganic pigments, and high performance organic pigments. And out of that, the industrial organic pigments volume wise have been estimate 2020 in the million tons, about 3 million tons of high performance inorganic pigments, and commodity inorganic pigments like titanium dioxide and carbon black about 8 million tons, amounting to 11 million tons, 110 lakhs. Industrial organic pigment value wise is about close to 27 billion US dollars, and which includes this of, you know, high performance inorganic and commodity inorganic both. You will find that world industrial synthetic organic pigments are very meager as compared to the industrial total colorant. It's amounting to only 5%, so about 5 lakh metric tons of classical commodities, polycyclic and high performance. And out of the 5 lakh tons of industrial capacity the world has today, which is amounting to about 42,000 crores, you will find that the classical commodity pigments are 3 lakh metric tons, and polycyclic phthalocyanins including is about 1.7 lakhs, and high performance organic pigment for which only 30,000 metric tons. And you see the situation here changes. Almost 4.7 lakh metric tons is just half, and only 0.3 is 15,000 crore, because the reason is, you see, the $7 and $8 and the $60. So it is India who is deprived of, you know, the high performance pigments, and in the post COVID-19 this will be a very great challenge for us. Now, world organic pigment, you see the country region that total about 5 lakh metric tons, and you know, India is 7,500 crores, China is 13,000 crore, US 6,000 and something like that. Out of this 7,500 crore, I think the 2,200 crores is actually local consumption, and about 5,000 crore is 5,200 crores is about export. So high performance pigment, if you see out of that small segment, which is about 30,000 in 2000, we had a very simple 15,000 metric tons, which in 2020, in 20 years has become 30,000 tons. And this is the chunk of the business, the major, the money, the 50% of the value comes from that, only 5% of that, you know, high performance pigments. So in the year 2000, we have NAFTA, Europe leading, and in 2020, we have, you know, China and India leading. Estimate for 2020 pigment industry has been meagerly, you know, you see 13,000 crore is the Indian organic pigment industry and about 7,500 crore organic industry. And out of that, the local consumption, as I said, 2,200 crore, and the export was 5,363 crores. Out of classical inorganic pigments, the carbon black, the zinc sulfur, the aluminium, zinc dust, titanium dioxide, iron oxide, chromium oxide, lead pigments, ferrocyanates, silicates, ferrocyanides, ultramarines, and nitrides and oxides have been common in classical inorganic pigments. And for classical azos, we have various chromophores like azo, carbon double bond, carbon carbon bond, carbon sulfur bond. So these are classical organic pigments, which are monoazoclassical. These are disazoclassicals, naphthols, lakes, rubines, phthalocyanins, blue, greens, and nitroso pigments. Now the high performance inorganic chemistries have been about inorganic chemistries are like aluminium flakes are high performance, metal oxide pigments, mixed metal oxides, micaceous iron oxide, bismuth vendate, cadmium sulfide, nano silicon pigments, quantum effect pigments, doped rutile pigments like of doping of nickel and chromium and the manganese, and the complex inorganic color compounds, color pigment like CICP, the titanates, the chromides, the oxides, and cobalt coated. These are the high performance inorganic pigments. We have also the effect pigments, but will come later. And high performance organic pigments have been about 12 chemistries which are major. You believe these, these all 12 chemistries have come between 19th century till 1975. The last chemistry came diketoperolepyrrole in 1975, which was by Dr. Iqbal. He was a Bangladeshi working in Switzerland. But 1950, 1960 witnessed the heydays of the organic pigment industry, and 60s and 70s were the advent of high performance pigments. So quinophthalone, quinacridone, perylene, benzimidazolone, Azure Condensation, perinone, dioxazine carbazole, isoindolone, phthalocyanins, diketoperolepyrrole, isoindolone, and imidazole anilated triphenyl oxidines. These have been certain chemistries which have been very popular within that 30,000 tons, which is demanding a price of 60 to 70 to 80 to $100 a kg, and mostly these are for the world market, and India is a net importer. So post COVID-19, this would be a situation where we talk about later. The special effect high performance pigments are nacreous pigment like metallics, like oxides, like mica coated metal oxides, the platelet monocrystal pigments, the comminuted polymeric LCD type, natural pearlescence. Natural pearlescence, out of 1,000 tons of the fishes, only 250 grams of natural pearlescence is available. So such a high cost, very high cost, very high price commanding situation. Pearlescent, high performance pigment, luminescent, night glow, day glow, micaceous, the comminuted again thick film, and the interference pigments, and BiOCl. BiOCl is bismuth oxychloride, the top gloss. Whenever you see a nail polish, whenever you are able to see from the glass, a color, impact, and a density and impact, it is the BiOCl pigment. So maybe we come to our subject of high performance organic pigments. It's not only a chemistry, but it is also a physics and engineering and technology. It's a marvelous confluence of architectural designs, crystal design engineering, and the key driving factors have been the molecular size, the molecular weight, the molecular structure, the crystal structure, polarizability, dipole moment, conformation of structure, constitution. The crystal memory is very important here, energy, particle size, crystal habits. As I said, even water has a memory. Water comes to you with so many pipes and vents, and people say, don't drink directly, keep it. Elderly people and ancient people used to say, drink it from the river only, don't drink it from this thing, because water, the H2O, has a huge memory. Every pigment crystal has a memory, like reflection hardness, cohesion, zeta potential, solubility, absorption, conductivity, hysteresis curve, magnetism, agglomerates, thermal stability, coloristic properties are very small thing in that, and light fastness, weather fastness, filtration, and dispersion technology. Because almost all nanopigments are, almost all high performance organic pigments are nanopigments. They are nanopigment means crystal has got a huge to do, but it is not a plain crystal. And mostly all the high performance pigments have been as a counter to the inorganic pigments. All inorganic pigments had a very high light fastness, weather fastness. Organic pigment like classical azo and also polycyclic did not have the answer. So people tried, and 60s and 70s witnessed a lot of research only creating such a crystal density, such a huge compactness and crystal memory and crystal designing and engineering, that they brought different molecules. And these molecules are basically the answer, and they became nano in the whole process. And nano becomes its own a problem. They were mostly replacing the plastic technology, and it started creating the nucleation. It started creating the warpage and so many other things. So it is not a chemistry alone. It is almost a total diaspora and Pandora box of the system. Now the high performance, we as such consider the light fastness on 1 to 8 scale on blue scale, weather fastness 1 to 5, heat resistance about 300 degree, chemical resistance on 5, alkali. But nowadays you see, like many people think phthalocyanine is a high performance pigment. It is not. It is a commodity. It is within the price and within the structure, it is the best. However, there are many variants of phthalocyanines like silver and gold which are better. But when it comes to the ordinary, whatever copper phthalocyanine pigment blue 15.1, 2, 3, 4 and alpha, beta, gamma, delta, epsilon, what we are saying, they are not. The basic test is, you see sodium hypochlorite, you put your phthalocyanine blue or green, it will disappear. It means this is not high performance pigment. But anyway, it has been considered as a high performance here. So the high performance organic pigment applications have been, printing ink industry consumes only 5%. That too very digitals mostly. But coating, automotive coatings, industrials have been leading at 50%. Why inks don't consume? Because inks have a very short life. Today they are printed, tomorrow they are forgotten. So huge consumption. Though the organic pigment, 55-60% of the worldwide organic pigment consumed worldwide are going into coloration of the mass coloration of the printing ink, and the paint is just very meager. But when it comes to the high performance pigments, it is the coating industry which is leading 50%, and the plastic industry followed, because advent of high performance plastics were all high performance pigments were for plastic industry. And of course, the new areas like digital emerging technology, like organic electronics, like flexible electronics, like CD compact device, like DVD, digital devices, universal devices, and also solar and semiconductors and organic electronics. These have been the very emerging CAGR 10-12%. They are rising very high grade. So high performance organic pigments, we have to see the chemistries, we have to see how we have to come up. So that is finishing techniques. We have to see the branding and marketing and legislation and ISHA before we finish the subject. So I'll just run through some of the 12 chemistries of high performance pigments. Particularly first chemistry in 1950, since 1950, benzimidazolone, where we have the family of pigment yellow 151, 154, 175, very beautifully designed chemistries, and high alkali resistance, soap resistance, light fast, weather fast, and chrome this thing. Benzimidazolones are basically azo, but because of the two couplers like 5-acetoacetyl amino benzimidazolone and 2,5,2 hydroxy naphthalene amino benzimidazolone, when these act as a coupler, you get something like that. They have light fastness on 1 to 8 scale about 7 note lesser, and the weather fastness also, instead of 1 to 5, 5 is still considered high performance. Migration is 5, and the heat stability is slightly lower, 270, because of the benzimidazolone structure. So there is a pigment yellow 151 like passion yellow or Maruti, the very famous color. The Hostapum yellow H4G was the Hex Clarion product. Then second is diketopirolepirole. Of course, this was last, as I said, 1974, discovered by Mr. Dr. Iqbal. This is actually the Reformulation reaction, which is the bendonitrile and the esters. And this is a very good product delivery system of pigmented 254. You see, pigmented 254 has got light fastness about 8. Weather fastness is also on the dark shades about 4 to 5. And migration is 5. It doesn't bleed in any of the plasticizer, it doesn't go in any of the solvent. And heat stability, the molecule is so compact, so diketopirolepirole structure like this, so high heat stability. Now that come to the imidazolone, anilated. It is a new system. It is in 1960. It is actually when we go to the pigment violet 23 chemistry, I'll tell you, which is dioxazine carbazole. But here the chloranil is with the 5-amino benzimidazolone. It is a combination of benzimidazolone condensation with the chloranil instead of N2-ethyl carbazole, and you get a pigment blue 80. This is our highest color strength pigment available, our highest. None has matched the color strength development of like this pigment blue 80, the two benzimidazolone anilated and the carbazole in between. Similarly, we have a quinactolone pigment. It is actually a fantastic pigment. It has been since it was a dye basically, but pigmentolo 138 has come in a picture. The quinaldine and phthalic anhydride is fused, and then you have a fantastic Pandora box of the colors, like pigmentolo 138. It is being manufactured in India. Then we have high performance isoindolenone, presence of isoindolenone ring, which is pigmentolo 139, and like this we have pigmented 260 isoindolenone ring. Then we have tetrachloro isoindolenone, pigmentolo 110 or 109 is a tetrachloro, this thing, the tetrachloro moiety, which is improving the light fastness, weather fastness, and heat resistance because of the halogens. And then we talk about phthalocyanins. Of course, this is the structure which is almost 4 moles of urea, 4 moles of phthalic anhydride, 1 mole of cuprous chloride. And it has been used in the DVD. It has been used in the various compositions like plastic master batches, high performance, coatings and things like that. But the pigment has been available since 1950. It's almost 70 years have passed, and it has fallen into a commodity. And that's why you see in India, because we have our agriculture economy, we had plenty of urea, and we also had a phthalic anhydride to our credit. So in Gujarat, we have almost world's largest capacity of phthalocyanins manufacturing capacity developed unintentionally, intentionally, whether we use the urea for the agriculture purposes, into the industrial purposes and whatnot, all have gone into the history. But today we see India is the biggest producer of phthalocyanin blue, the crop phthalocyanin green chemistry in the world. And many people have set up, because we have chlorine available, we have phthalic anhydride available, and we have here. This is what happens when you have a supply chain, COVID-19, post supply chain we are talking about, like this only. If you have material available, if you have raw material available, many people will go and they will talk about product, and then the industry and the country and the society will gain employment and knowledge and the research and also the general GDP growth. So we talk about, phthalocyanin is a very symmetrical molecule with the center of copper. Here we can keep on changing copper to silver to iron to lithium. Anything can be possible in the copper phthalocyanin. It has fantastic memory. It has a fantastic memory storage, and this can be used in the Blu-ray DVD, like Moser Beer had started this. A refined phthalocyanin, which may be available at $6-7 a kilo, but if you go on refining the things like copper and metal-free phthalocyanins, it can go up to the 10,000 rupees a kilo, maybe about $60, $70, $80 a kg is possible. And of course, when you talk about changing the metal here, like instead of this is about 9 to 10% of copper, if you can have about silver and the gold, it can be still a fantastic memory for your diverse, variable the DVDs and the compact discs and the memory enhancer things, because the molecule has fantastic memory. So for organic electronics, etc., it is best. The quinacridone pigments were invented in 1958. There are many routes, but the biggest chemistry exploit has been from dimethyl succinate, and with the help of sodium methoxide and the Claisen condensation, you have a ring. Then this is Claisen condensation makes it, and then you have a cyclization, and then you have to produce DMSs, that is dimethyl succinate, and then you have a coupling amine and also a polyphosphorus acid. Normally it is condensed, and then you have pigment violet 19, quinacridones, and pigmented 22. They exist in morphologically alpha, beta, gamma, epsilon forms. And then you have a fantastic material which is still fantastic memory, a very symmetrical material, and a compact material, a very high energy density and crystal designing simplicity. And you get a light fastness about 8, the weather fastness about 4 to 5, in full shade migration is 5, and the heat stability is 300. Excellent material for the magenta shade for printing inks, for digital, and also quinacridone pigment red for almost all automotive applications and industrial applications with exterior durability. Then we have Azure Condensation. In 1950, Dr. Smits of Hex, they decided instead of, same Azure pigment, they started whose molecular weight is only 400, 500, we can have a molecular weight increase by addition. So instead of, say they took a basic amine and then they condense with, this thing, and then they bond an amine condensate coupler, and then they try to doubling up, the molecule. And then a huge host of families were born, which have high light fastness, alkali resistance, soap resistance, weather fastness, and chemical resistance. So there was a product called, pigment yellow 93 red, hostopum yellow FGL, whose light fastness on 1 to 8 was about 7, weather fastness about 4 to 5, migration 500, and heat stability about 280, which is fantastic doubling. You see the memory of the crystal designing and the symmetry. Then you have a condensation of the azo, and then you can find the azo bonds here and here, and then the two azo bonds, despite so much of benzonide structure, still it has light fastness of 7 because of the molecular weight. Then we have perylines. This is PTCI, perylene tetra carboxylic acid diamide, and then condensation of this with the amination, the PTCI production and PTCA production, and the amination. This is another fantastic memory crystal molecule of pigment violet 29 and pigment red 149. Huge energy packing density, cannot be disintegrated by the light and vagary of weather and heat and solvent, all that. Fantastic material which can be used in automotives, digitals, and also the plastics application for the high performance. India is not producing all this. Now we come to finishing the technologies of organic pigments. Why we focus on this? Because India is a net importer of all this. We don't have. Nobody manufactures. People manufacture chemistry, but the finishing is not there. It is like a finishing, when I say you have out of a marriage, when my boy and my daughter-in-law, they produce a child. No, simply child production is not the purpose of marriage. It is how to raise up a child, how to bring her or him up, how to educate, how to give sanskar, how to give clarity, concept, courage. All that is possible in the next 25 years. That is called finishing. So when a child goes to a school, say a small dress, then other dress is, when it goes to, the park, or another dress goes to when the school, other dress when he goes to, the party, other dress when he goes to a, puja, or maybe when he goes to sleep, another dress. So child is same, dressing is different. So the pigment finishing techniques require, engineering and technology, physics and technology understanding, and chemistry and technology of understanding. The partial pigmentation and full activation is following, engineering and technology. The pigmentation of activated high performance crude, otherwise pigment is crude. So physics and technology, and the chemistry and technology, the post treatment for the HPP in different application. So pigment finishing techniques, engineering and technology, we use a lot of mechanical energies like sound, like resonance, and sono, and also sound energy, the ball mill energy, the size reduction, the shear, the cascading, the attrition, milling, sand milling, etc. These things are just to make the whole breaking down, the unpigmentary large crystals into the and also to remove the impurities and create the freshly prepared surfaces amenable to pigmentation. If you don't make a size reduction, the long unpigmentary crystals will never attain the pigmentation process. Some of the additives are there which is actually cross-reference only for people those who understand how it is possible. There are pre-treatment additives. Then we have the finishing techniques in physics and technology. That means when you have activated the crude, when you have a partial pigmented the crude, when you have attained the breaking down the agglomerates of the crude, and then you have a large pigmentary crystals yet to be, so then you have to apply solvent reflex, the salt kneading, the high pressure, high temperature ball milling technique, and there are various other secretive techniques which are used. for making the pigmentation of the activated crudes. And then there are certain things which are adjuvants and finishing additives which are being used, like surface actives and coatings and synergies. There are some of the products which we sell. The pigment finishing techniques for the post-treatment of the crystal are actually 3 phases. One is aqueous, highly polar, that goes for textile, for leather, for paper, for artist color, for all these things. And the other is solvent techniques. These are for non-polar, for mid-polar, and the polars. And the third is solventless. That is almost all your plastic composites, plastic master batches, powder coatings, LD, HD, PP, nylon, PET, coloration of mass coloration of all these things. So we have 3: the solvent, the water, and the solventless. These 3 applications that we have to have understanding, that post-treatment for the aqueous application, almost all HPP crudes for pigment paste, for water basings, for coatings, for artist color, for textile, leather, paper, detergent, cosmetics, and construction, you need to have coating agents which are actually auxiliaries with affinity groups, which are capable of forming the monomolecular layer all around the pigment crystal surfaces and taking care of the zeta potential and the ionic double layer. And here it's a question of monomolecular layer. I'm talking about, this is a just basic requirement of 100% coverage of the monomolecular layer. This is the minimum. If there are half coated, and somebody in the earlier days, somebody asked, that how much percentage, and the person from the BYK could not answer that. But let me tell you, it has to be the 100% monomolecular layer. If there is a coating left, that portion of the uncoated pigment crystal would solidify with the coated crystal and would start romanticizing. And then what will happen? Flocculation. So because the birds of the similar feather flock together, if you have same coating, it repel. Spherical is hindrance. But if you don't have the same coating and you have half coating here and half coating there, the uncoated of here, the coated of here will start romanticizing, and your pigment flocculation will take place. So for high performance pigment, this is the much more important thing. It is not important in case of inorganic pigment. It is some importance for case of organic pigment like azo and disazo and naphthols and lakes and rubins. But it is highly important of a finishing technique when it comes to high performance pigment. High performance pigments are the curse if they are not used properly. They are tremendous energy, tremendous memory, and tremendous tracking density if they are not coated. So not monomolecular layer, multimolecular layers are required. And then you have certain additives which actually can do these jobs. And then we have pigment finishing techniques for post-treatment for non-polar systems, like for offset, for synthetic enamels, for polarity is mid-polar, I would say. And these are mostly cationic polyurethanes with the pigment affinity group to form the monomolecular layers adsorbed on the pigment crystal. And then we have certain products to suit the requirement here for high performance pigment, which we are selling to China. And also now we are talking too much at the moment with the various pigment people here in India also. Then pigment finishing techniques post-treatment for mid-polar and strobing finishes like polyamide, maleics, EVA, phenolics, nitrocellulose, vinyl, polyurethanes. These are liquid systems which are actually finishing techniques where we have to do our high performance pigments for these applications. And then we have to have another polarity and another design chemistry. Some of them are for illustration given here. Then we talk about the polar systems, which are MIBK, MEK, and solvents which are quite polar, and particularly epoxy, epoxy MF, epoxy polyamide, epoxy phenylcamine, or epoxy polyester, or epoxy TGIC, or acrylic polyol, isocyanates, or polyester polyol and isocyanates. Various things are polar. They warrant a polarity. As I told you when I discussed the bird of similar feather flock together, it is not possible that a black crow will flock with the green parrots. The green parrots will flock with the green parrots, and the black crow will flock with the black crows. So OEM coatings, aerospace coatings, PEI based coatings, PEEK based coatings, polycarbonate based coating, polyurea, polyaspartic, and PSS based conductive semiconductor poly, all these pigmentations you require, a different poly treatment. And for that, some of the illustrated auxiliaries, there are several, but I think some numbers are here. So pigment post-treatment of the solventless is the biggest problem. It is not monomolecular layer. It is multi-molecular layer. You cannot treat same way as you have treated for the offsettings. You cannot treat the way you have treated with the automotive coatings. Here we are talking about plastic. In order to get 1/3 depth, you require 0.001 pigment. And that too, at that level, you have low MFI, LDP or HDP, and these don't have any polarity. They will not disperse pigment. And it would be a forced cohabitation of a pigment in a master batch. Let me tell you, about 60,000 or 70,000, about 1 lakh ton of master batches are produced. They are produced on ZSK82, Warner-Lee Bartos extruder. They don't understand the pigment. They only forcibly cohabitate the pigment, and they, without understanding the pigment, they are simply, that is called regardo. That is all gesto, and then the pigments are not like that. And that's why for the thin film application, for trivial application, for almost all high applications, we are failed. We are not a pigment master batch manufacturer in country where everything is imported for all thin films. So basically, the finishing required is as high as about 50%. There are many patents. There are about thousands of patents of the high performance pigments available, which are treated, post-treated, almost resinated to suit the plastic application requirement. And then there are certain.
Doctor, you have another 5 minutes. Doctor, you have another
5 minutes. Yeah.
I'm coming to that.
Now the 5 minutes will be required question answer. That is the last.
Okay. So I am coming to last slide. Way ahead for India is making of a community or a country or a company or a chemistry is a never-ending job. It's a never-ending process. It keeps on going. So keep moving, keep working, because journey is better than destination. And thank you very much. Thanks for your attention. I think it was a subject which actually I had to rush up. Sorry for that. Thank you very much. Question and answers.
Thank you very much, Dr. Subhash ji. This is Bengeri, chairing the session.
Yeah, Bengeri. Yeah.
That's nice to hear you, sir. And you are the best person to hear on the pigments, which I have hearing for the last 32 years, and taking the guidance from you all in the printing industry. And one question from me is the pigment green 7 and pigment green 36. Are the strengths are the same or are different ones?
See, pigment green 7 is a 15 molecules of chlorine, and the pigment green 36 is 1 molecule of bromine into it. So when you say brominated phthalocyanin green, it is pigment green 36. It is a yellower tone. So you cannot compare the two tones, because pigment blue 15 pigment green 7 is a bluish tone and pigment green 36 is a yellowish tone. So the two are different.
Property wise, both are okay. But property wise, both are same.
Oh, property wise, light fastness on 1 to 8 scale 8, weather fastness 1 to 5. But when it comes to sodium hypochlorite resistance, they will fail.
Oh, okay.
Nowadays, sodium hypochlorite is more popular, as a sanitizer,
Yeah.
So it is
one more question is the high performance inorganic pigments. But they also cannot be used for any good manufacturing practice and other things like that.
See, when it comes to high performance inorganic pigments, there are variety of inorganic pigments. And they are mostly colorless. Of course, there are some interference pigment, there are some pearlescence pigment, and some tone is there, but they don't have the color strength. So high performance organic pigments come for the color, and for the opacity and for other brilliance and other things, high performance inorganic pigments are warranted. So it's a combination always.
That's thank you very much, sir. Aditya ji, you have any other questions, sir?
Sir, I have one question. Please allow me. I am Pradhan here.
So Pradhan sir is there. I think so. He wants to have one question, sir.
Good afternoon, Mr. Srivastava ji. Very good presentation. I have one question. You see, you rate copper phthalocyanin is an inorganic high performance coating or inorganic pigment. You then said another question. One minute. Let me finish. Well, let me finish. There is another sub question. You mentioned one blue in the organic pigments, which has got a better light fastness than phthalocyanin blue. How do you justify that in absence of the metal molecule?
No, hello. See, basically, I said pigment blue 15.3, pigment green 7. They are phthalocyanin pigments. They are organic pigment. They are polycyclic pigment. But I said they are organometallics in nature, because 10% is copper or a metal and 90% is organic moiety. So it is, I think, if you see what is more, organic is more. So they fall in organic. They are 10% inorganic and 90% organic. So how to say such a blend? It is organic, inorganic. But for all common practices, being 10% copper in phthalocyanin, it is considered organic. So it is organic polycyclic, number one. Number two is, when it comes to, the performance of, and the color strength, there is a annihilated dioxazine carbazole benzimidazole pigment blue 80, which has the highest color strength as compared to phthalocyanin also. So phthalocyanins are, for the price, they are best pigment, blue and green. But when it comes to the performance, there are better pigments also in the line. Okay, but they are not yet not commoditized and yet not commercialized. So you don't see them, like pigment blue 80. I mean, nobody has heard of it, in the global area here. Such a thing is happening. But all phthalocyanins are like battery, 90% organic, 10% metal, the positive and negative charge. So they all happen to be flocculation, crystallization, so many problems with the phthalocyanin polycyclic. And the bigger problems are existing with the high performance pigment, which are technically nano pigments. You understand?
Aditya, if you can answer some questions from the public participant,
Yeah, there are questions, but in terms of time, we are already 4:20 is the next session, so we can send the questions offline if you want. So
yeah,
Aditya, you can ask any one of them now, one or two.
You can take one question at least.
Yeah, I'll take one question. Just let me see.
Whoever is the senior most.
Yeah. So I have one question from Professor VC Malche.
I would like to reply. Yeah.
How far have Garda, Sudarshan, and Ubec colors come close to international requirements of HP pigments? I think you can answer, and maybe then Surendra ji can also answer in his
No, they are great people. Let me tell you, with no support, these companies which you named, Mr. Dr. Garda, like, Sudarshan, like, so many people, without the support of Europeans and Americans, because these Americans and Europeans, I'm sorry to say, they have offloaded only commodity pigments to us, where the margin, even the packing cost is not recoverable by a manufacturer. So in absence of such help, no governmental help, no technological help, no academia and institution, research. You remember all these 1950s, 60s, 70s, all these high performance pigment or all these great chemistries have come to world only by industry support. The Hext, the Bayer, the IG Farben, and the SIBA, all were, hundreds of universities together. They funded. There was an endowment. There is a huge amount of PhDs produced. See, each word is so high, but against all the odds, these people, like what you say, Sudarshan or Garda or Amar came, or even for that matter, the Color erstwhile my ex company Color Chem Limited, we were all doing, despite all the odds, a lot of work. But chemistry is not the only thing. That's what I want to tell you. In high performance matching chemistry, anybody can do if the raw material is available. I'm talking about understanding of that high performance pigment, that it is not only chemistry, it is a physics, it is an engineering, it is a crystal design, it is the morphology, it is polarizability, it is dipole moment, it is memory and inbuilt memory and lot of crystal habits, so many things. And then post treatments, the surface treatments. It is not the straight, when the chemistry is made, HPP pigment violet 23 dioxazine carbazole, you take the N-ethyl carbazole and chronically condense it and give it to the customer and he's happy. No, it is not possible like that. You have to see a lot of post treatment, lot of covering of your child, and then only it becomes a commercial pigment. There they failed. Each one excelled in the chemistry.
I think we'll discuss in detail. Aditya san, if you can take it, some question, we'll send it to Dr. Srivastava.
Yes, I think in interest of time, let's go ahead.
Next session.
Yeah.
And,
So
thank
we'll
you
go
very
ahead
much,
and-
Dr. Srivastava.
Thank you, Dr.
Thank you,
Srivastava.
thank you. Thank you. Thanks.
So for the next session, technical session, I'd like to. It was a good. This question was a good introduction for the next session also. So I'd like to invite Mr. Surendra Gupta ji, who's the GM at Marketing and Sales, Hubac Color. He obtained his MSc Tech in Dyestuff Chemistry from ICT and pursued further PGDIM from Mumbai University. He is presently associated with Hubac Color Private Limited, which is a German MNC, as GM Business Development and responsible for global marketing and sales functions. So he has been with Hubac for about 16 plus years and served across multiple functions, so R&D, project, and production. He started his professional journey at Thai Ambika Chemical Dyestuffs Manufacturing Company in Thailand as a project and production manager, and later moved to Nigeria, where he was involved and responsible for new greenfield reactive dye manufacturing plant. Surendra Gupta brings with him strong track record of business leadership and performance delivery, and in the global colorant industry. He has been widely traveled across the globe and having experience of setting colorant sales networks in Japan, Korea, Brazil, and other countries. With this, I'd like to invite Mr. Surendra Gupta for his technical session.
Hello. Hello.
Yes, you are audible, Surendra. And your screen is also visible.
Okay. Thank you, Adit, for your kind words of introduction. Friends, very good afternoon. It's my pleasure to be here joining you via new mode webinar. And when Rohan talked to me a few days back on last Saturday of joining the Color Society, and he mentioned about my classmate Prakash Manevar getting fellowships, I thought let me join this webinar. And I would like to congratulate Color Society and its office bearers for organizing this event today under COVID gloomy atmosphere and trying to rejuvenate everyone involved, and of course bringing different discipline of paint sector on a single platform to discuss and share knowledge for overall benefit and growth. I would like to also thank Dr. Srivastava for setting up the tone of the presentation. And it's very difficult to make a presentation in a webinar mode where you really do not see the audience. And I got Adit, 1 second. Adit, I got some issue of showing my screen.
Screen is visible. You just need to maybe use your keyboard front and back. You can go to the next slide.
Okay. So friends, as the world begins to its slow pivot from COVID-19 crisis management to recovery and the reopening of the economies, it is clear that lockdown has had a profound impact on how people live. The period of contagion, self-isolation, and economy uncertainty will change the way consumer behavior, and in some cases for years to come. It is going to impact us all. In today's presentation, I shall try to briefly touch upon some of the aspects about COVID effect, few commercial and points. Adit, I'm still facing the same problem.
Aditya, you have that presentation. If you can show the presentation, then he can.
Yeah, it's.
Mr. Gupta, this is Abhishek here. Your screen is visible. We can see your screen. I guess you have
But
to.
I cannot, the problem, I cannot move the slides here.
Okay. 1 minute.
Aditya, you have that presentation, I think.
Because it is being hanged.
Aditya, whether
Surendraji, we can play the presentation from our end. Just if that is a problem, and you can just give us a couple of minutes. We can load it from our end, and then you can just.
Okay, can you see now the content slide? Can you see the content slide now?
No, not yet. But we can play it from our end if there is a problem.
you
So here, which slide?
Just a minute, sir.
Okay, now it's again coming back.
Yeah. Now it's there. Can you check if it's working?
Okay. Yeah, it's working. Sorry, everyone, for the technical glitch. So coming back to the content of my today's presentation, I would like to briefly touch upon COVID-19 effect, few commercial and technical aspects, development in the area of pigments, and fallback smart offerings for the coating industry. Before we move to COVID-19 effect, I would like to run you through Indian specialty chemicals size, putting a larger canvas in front of us to navigate through different sectors, especially the colorant industry of our interest. Adit, it is again getting jammed, not moving. Sorry.
Just give us 1 minute, Abhishek. If you can just play the advertisements, we'll just get back to you in a couple of minutes. We'll play it from our side, and Surendraji, you can just explain.
Neha.
Please bear with us, everyone. This is a short technical break. We'll be back to you as soon as possible.
Yes, Adit. Yes. Yeah.
Can you see the screen, Surendraji? Your slide, first slide. Hello?
I can see.
Yes. Okay, so I'll play it from here. I'll just go to the second one, and you can then accordingly tell me when you want to change the slide.
Okay.
Just a minute. I'll just go full screen. Yeah. Okay, go on, sir.
Okay, friends, sorry for the technical issues. And that's what we are doing right now in the webinar. Coming to my content of my today's presentation, I'm going to briefly touch upon the COVID-19 effect on the Indian industry, specialty industry, on the colorant industry, what is the effect and how to really ride through COVID-19 effect, then moving to the technology part, different performance criteria for the organic pigments, and of course coming to the Heuberg smart solution which we are offering to the coating industry. Next one. Okay, before we move to COVID-19 effect, I thought let me just take you all towards the chemical industry. Where are we, and what is the global chemical industry market? If you see here globally, we can divide into three main categories: basic chemical, specialty chemical, and knowledge-based chemicals. All together is approximately $4.5 trillion, whereas Indian chemical industry is standing at $150 billion, and out of that, specialty chemicals where we belong, India specialty chemicals currently at $27 billion and growing at a very healthy rate, almost double than the normal global growth, and it is expected to touch to $48 billion by 2023. So friends, we see a very tremendous growth opportunity to become a larger part into Indian Atmanirbhar program, and really making the $5 trillion economy a reality in near future. And another one point we said that inclusion in the economy by the chemical is really putting $5 in the other sectors. So we have got a lot of scope in growing in the specialty chemical. Moving to the second slide, which is on the colorant industry. Next, please. Here on the top you can see the global colorant industry which is standing at approximately $36 billion, whereas the Indian colorant industry size is approximately $6 to 7 billion. Indian colorant industry, which comprises the dyes, intermediates, and the pigments, having a percent. Dyes and pigments are almost 29% in Indian colorant industry, and the intermediate, which is a bigger part, and 47%. Current market share of Indian colorant industry is approximately 20%, and it is expected to grow further in the future. The market share is expected to grow due to various changing dynamics and the new opportunities which are coming due to various factors. One of the very important point which Dr. Srivastava also touched upon his presentation, in terms of enhancing the value chain, how to move to higher value added product range and how to really bring value out of our efforts. And that is going to be a very big challenge for us, and in fact an opportunity in the Indian colorant industry sector. Next one, please. COVID-19 effect. Coming to the COVID-19 effect on the chemical industry, as a typical black swan effect, COVID-19 took the world by complete surprise, with many facing government-imposed operational restrictions, severe supply chain disruptions, and declining consumer demand. Here you can see the effect. Chemical industry potentially be hit hard by COVID-19 outbreak on numerous fronts: demand, lower productivity, operational supply chain. Second one is specific on the human, the workforce, the vulnerable, given that the bulk of its production workforce is in on-site jobs that cannot be done remotely. Right now, we all are, can do our conference, our seminar by work from home or sitting at a home, but a production in the chemical industry cannot be done. And given the nature of industry, companies may need to consider how to create social distancing in workplaces that are often work dense. On the top of this, the another factor which is really affecting is the global supply chain and other distribution disruptions. It is all likely that tomorrow we can come out of the COVID situation, but maybe our suppliers sitting in some other country, or maybe our users sitting in other country is still affected by the COVID. And that is where the challenge is coming during this crisis. Finally, the expect slackening demand of the product resulting from some industrial impacted industries like automotive and industrial products, which we are also witnessing here in India. Yet there is some silver lining. We could simultaneously see a continued demand in other end users such as products for personal health, household products. In the last few months, you have seen the packaging industry is doing good. FMCG is again coming back to pre-COVID time period. Next, please. Okay, so how to address and outmaneuver such a pandemic situation? Here we need to think of on a different 5 bigger horizons to address the COVID effect. To name it, resolve, build up the resilience, return business back to the normal, reimaginations once the business is coming back to the normal, and the reform. And coming, I will just like to address the first point about the resolve, address the immediate effect. And the 3 focus area for this is the safeguard people, manage supply chain disruption, and the most important is the manage working capital and business plans. And this can be, you can consider these are the 3 karmic elements of our livelihood. And we need to make attention to all 3 in the similar strength. And how to do it? I'd taken a very good slide from the McKinsey report where they have suggested, in fact, at our company also we had implemented and it is working nicely to create a nerve center. Which is really defining nerve center with the focused, agile, cross-functional and highly empowered to take quick actions. Here the speed matters to protect the employees, how to manage the production flexibility because affect due to the raw material unavailability or due to the disruption of the supply chain, screen and safeguard supply chain, protect our margins. And basically to protect our margins, we need to protect our top line, our customers, and of course ensure the financial health, which is very important. So these are the 5 5 main points: working environmental, labor unavailability, raw material shortage, supply chain disruption, and cash management. And we can really tackle this by making a nerve center and addressing the different point and really riding through the COVID situation. We are from at our end, we are really very optimistic that this time will also pass and then we will be back to the normal. Which kind of recovery, it is very difficult to say whether it will be V-shaped recovery or it will be U-shaped recovery or it will be L-shaped recovery. Only the future is going to tell us. And in this regard, if you would like to see whether recovery is coming, one can really watch the coal consumption or the energy consumption data as a proxy to returning to overall growth. Finally, friends, there is no magic solution to address any pandemic, and I would like to quote here Charles Darwin. It is not the strongest species that survive, not the most intelligent, but the ones most responsive to change. So we all need to be geared up and to be ready ready for the change and make accordingly our business plans and our policies. Next one. Coming to the second part of my presentation on the technology front, where I'm going to briefly touch upon the technical performance criteria and the various chemistry and technology tools for the elaboration of the organic pigments. The colorant industry is under greater pressure to deliver products that perform to higher standard both in performance and visually, all while meeting cost and environment benefits. Today's color trends are being driven by various influences from culture to technology to environmental issues. The green movement is another area that is having huge impact, and eco agenda are very more visible. With the new EU REACH legislation into force and many more existing or in the pipeline like MITI or JOSPA in the Japan, Korea REACH which is under implementation, Philippines and Thailand are also working in the similar line. Now India, after so many years, first time coming on the chemical inventory list, and the Indian BIS is working on this. Brexit effect, where the US is coming with own REACH, TSC in the USA, Mercosur in the South America. So there is a plenty of regulations which are coming up in the global scenario, and we cannot really shy away from this. And in fact, this is providing us a golden opportunity to become global supplier in the colorant. Next slide, please. Before we go to the technical part, I would just like to touch briefly upon how the colorant industry has moved in the global. If the science of color comes from the West, with the great discovery of color originating mainly from the Germany and UK. In EU during the period of 1870 to 1950, and that was the initially industry setup. Like in the UDCD or when we go to the labs, we see the big volumes of the BIOS and the Fiat reports, and then come the first migration. After the Second World War, with the new world order finding leadership in the USA, Japan is emerging as a technical and industrial country, and that is the during the period of 1950 to 1990. And then now we come to the very interesting period, where the second migration has happened during the period of 1990 to 2010, and which is continuing till date. That is the migration of the colorant industry from the Europe, USA, Japan to India and China. And now presently we see a different kind of market migration in the global colorant industry, and that is in the form of M&A, merger and acquisition. Like recently the DIC acquiring the BSF pigment business. Clariant has already announced to sell its pigment business, looking for a suitable candidate, and I think they are going to finalize by this year end, which is already delayed due to the COVID. Few years back, Ferro bought Capale, and the USPE from HIG buying Canada-based DCC, and recently they have bought another company, Lensco, and the merging and creating a new company, DCL. So we may see further movement in the future, and then new migration is coming in the colorant industry, where a lot of factories are moving from one place to another place, and globally various companies are looking towards India as a global hub of supplier of the colorant, especially the pigments. Next one, please. Okay, coming to the organic pigments, you can see on the performance side and the year induction, basically the organic pigments can be classified on the performance as a azochemistry, polycyclic chemistry, copper phthalocyanide, low performance, mid performance, high performance. And to be really honest, there is no clear definition of high performance pigment. A product which was high performance pigment few years back, or maybe at a time of introduction, now falls in a low performance and mid performance, and this is all due to the emergence of new technologies which are coming. So things are changing, and various high performance pigments are coming in this forum. Next one, please. Next. Okay, coating industry. Which are the drivers for the coating industry and where do we stand? If you see the Indian coating industry, which was around $7 billion, close to 55,000 crore in 2018, and expected to touch to $14 billion by 2023, and with a very handsome CAGR of 12 to 15% per annum. And we have just tried to put scene which are the growth drivers for the decorative sectors, which are in a global scene also and for Indian also. They are the two most important part for the decorative sector. The regular release of sustainable and eco-friendly products to the market. And the second, the stimulating the purchase of the color paints. The first one, which is the eco-friendly products, which is mainly coming from the environment context, and of course the stringent regulation and the social awareness which is coming now. And the second one is the color paint. Why the colored paint? Because these are more profitable, and paint industries are doing this in a two-way. One is the technology based, bringing large number of the colors to the consumers, maybe 20,000, 23,000. Sometimes these are confusing, but that is what is coming in the market. And the second is the marketing driven, enhancement of the customer well-being perception, that living in a colorful surrounding. Next one. These are the some coating industry trends and the requirements: zero VOC, styrene dispersibility and dispersion stability, good flow and rheology, high fastness level, free flowing, low dusting, versatile binder free, high pigment loadings, and of course the pigment concentrates. So these are the some coating industry and trends, and then how the organic pigment manufacturers or industries are responding to these trends. Next one. If you really see the current trends in the organic pigment developments, there is a no basic new molecule research which is going on. The last one commercialized was DPP by SIBA somewhere in 1983, and all the color trend is to improve application property of the existing pigments in a various different ways, either during the synthesis or by the post synthesis. And new pigment developments are in a various way by the way of the solid solution, by the new crystalline modifications, or changing the particle morphology, which is shape, size, or the particle size distribution, and modification of the pigment surface by broad arrays of the surfactants based on the end applications, and of course the ready to use pigment dispersions or the pigment concentrates. Next one. Okay, here you can see a very beautiful triangle for a pigment optimization, and the three edges of the triangle. One side is the chemistry, which is the heart of the pigment. Second side is the crystal, and then third side is the surface. The chemistry, which is really defining its fastness property, at what cost it is going to come, and what is the hue or shade, and which is actually comprising of different chromophores, and the crystal, which is the surface. By the modification of a crystal, pigment producer can make a product with a higher color strain, lower color strain, make it opaque or transparent based on the end application requirement. And the third is of the triangle, which is the surface. The modification of surface is per the final requirement, which kind of the resin or binder is being used by the end user or an application. So providing the right dispersibility, providing the required other properties. So these are the three basic fundamentals of the pigment modification or optimization which pigment producer influence. Next one. Just to extend the same slide, we can divide this modification in the two parts. One is during the synthesis, one is the post synthesis. During the synthesis, basically the crystal lattice modification, different kind of polymorphism or solid solution or combichem, and then post modification, which comes basically for the particle morphology modification. in the form of the post-synthetic milling, kneading, or different kind of processes which are really modifying or affecting particle size, particle surface or shape, and defining it as per the end application requirement. Next one. Just to give you an example of solid solution concept, which is being used in the different chemistries. In case of like quinacridone, like you can see here, combining the strength of the two different molecules, the substituted and unsubstituted quinacridone, where one can play as a guest, another can play host, and we can create a new crystalline structure which are having a very good fastness properties, hue stability, and one can really call it like a genetic modifications, or what we call in the metallurgy, the making the alloys. Basically the combination of the two different molecules and combining the fastness properties or the colorant properties of the two and bringing into one. And this is being used for much better pigment properties for high demanding applications like inkjet, toner or color filter, and now also in the universal tinter systems where one has to go for high pigment loading and also a stable universal tinter. Next one. Taking to the next about the Heuberg Smart Solutions, what Heuberg is bringing to our customers and our friends here in India, all over from the globe. Next one, please. Heuberg is a family-owned company. We have got a manufacturing located in North America, Europe, and India. We are located in the Ankleshwar in Gujarat. We have got also a small operation in the China, but that is not. There is no manufacturing in China, but it is only for the sourcing and the local sales operation. Next one. So. Three manufacturing facility which I indicated in last slide. We manufacture all our inorganic pigments and anti-corrosive pigments in Germany. We manufacture all our organic pigments in India, and our US facility is manufacturing various kind of dispersants for the North America and also manufacturing anti-corrosive pigments. Heuberg comes with a more than 200 years experience in the pigment field, manufacturing close to 63,000 tons of pigments globally. Employing more than 1,000 employees. Next one. Coming to the history, here you see the Heuberg is a family owned and started in the industrial business in 1350 in the glass, came to the pigment business in 1806, started in the US in 1984. Heuberg came to India when all the European company either they were migrating to India to India or China, and Heuberg Group decided to come to India and ventured into manufacturing in 1994. And I would just like to take a little bit back on the history of the pigment. There were the three main pigment manufacturer: DuPont, Bayer, and ICI. And Heuberg has bought the businesses from all three: DuPont in the USA, Bayer for light fast pigment in the US, and most important for the Indian context, organic pigment business from Avesia, which is formerly ICI, in 2002 in India. And that is how we ventured into the high performance organic pigment, because high performance or organic pigment manufacturing, the 50% part is what you manufacture there, and the 50% part is the applications. And here after the acquisition of ICI Avesia business, we extended our portfolio to the new red and the yellow pigment, which I am going to touch upon in the next few slides. Next one. This is our US facility. Next. Our European facility, where we manufacture all high performance inorganic pigments and our anti-corrosive pigments. Next. Here are our 3 units, which are all 3 are located in Ankleshwar, Unit 1, Unit 2, Unit 3. Unit 1 mainly for the blue and greens and also indenthrone blue. Unit 2 for the high performance yellow and Unit 3 for quinacridone and DPP red. We are now coming with our 4th site in the Dahej. The site is under constructions, and by next year we are going to bring a new product line from our Dahej facility. Next one. So what are the product range which we offer for the coating industry? Organic pigments, monolite and monostral. These are the brand names which came to us by the acquiring of ICI business. Monolite and monostral for coating industry. Organic pigments. Inorganic pigments, Hycoder and Venader. Anti-corrosive pigments of different product range in anti-corrosives, and different kind of hybrids, which are very important product lines, which are combining which I am going to touch upon in the few other slides. So hybrids like Ticos, the dispersion both in the solid phase and the liquid phase. So these are the product range from Heuberg. Again, to mention here, the organic pigments are all manufactured in India. Inorganic pigments and anti-corrosives are manufactured in Germany, and the hybrids we are manufacturing at our different locations. Next one. High performance organic pigments under the brand name of monolite and monostral. We touch upon the different chemistries in azo, isoindolene, benzimidazolone, naphthol, DPP, quinacridone, phthalocyanine blue and green, and of course another high performance range is the indenthrone blue PB60. In indenthrone blue, which if you see the automotive blue colors, which are mainly coming from the indenthrone blue, and Heuberg is the only global company which is now backward integrated in making own intermediate, which is the red blue 4, and we are going further backward integration to make our own intermediate for this important pigment. Next one. So these are our range from in the yellows: monolite yellow, yellow 74, both opaque and transparent type; diarylide yellow, yellow 83; isoindolene yellow, yellow 139; and the benzimidazolone yellow, yellow 151 and yellow 154, which are manufactured at our unit 2 at Ankleshwar. Next one. The quinacridone range, which we manufacture at our unit 3 at Ankleshwar. We manufacture both the chemistry red 122 and violet 19. Violet 19 we are right now only in the gamma phase, gamma type. In the red 122 we manufacture the 2 different types of the grades, and here I just like to indicate that we have recently expanded our capacity of quinacridone and come out with a very nice product based on our earlier slides which we discuss about the modifications of the pigment and the solid solutions, and that product is very good for universal tinter system. Next one. DPP range red 254, red 264 we are manufacturing at our unit 3 plant in Ankleshwar. Next one. Phthalocyanine blue and green, various alpha blue 15.1, beta blue 15.3, 15.4, green 7, green 36, both chlorinated and brominated green. We manufacture our own crude from where we got the technology from Japanese company. So here you can get a full range of phthalocyanine blue and green from Heuberg. Next one. Coming to the inorganic pigments, we manufacture high performance complex inorganic color pigments, which is the right chemical name. The another traditional name, these are also known as a mixed metal oxide MMOs. So we make nickel titanates yellow 15.3, chrome titanates brown 24, chrome iron chromite brown 29, cobalt blues, cobalt green, and spinel black. All these products are manufactured in state-of-the-art manufacturing facility in Germany, and these products are available for Indian market also. Next one. Another high performance pigment is bismuth vanadate chemistry, that is the pigment yellow 184, which we are manufacturing in Germany, and we have got a different grades, basically capsulated bismuth vanadate and non-capsulated based on the end application requirement. Next one. Next. Okay, the lead free formulations. This is an interesting topic. I think it's the topic which we need to touch upon. Lead chromates. If you really ask me, as a chemist, as a technologist, lead chromates are by far best color pigments invented and commercialized, providing all required properties at an optimum cost level. But it carries a very big negative point, and that is what is affecting the human health. And globally, and also the Indian paint industry have already taken the step to move away from the lead pigments and employ other product range in the place of the lead as a lead free formulations. And here Heuberg brings you a ready formulations, either in the form of a monolite and our vanadium range, which is the CICP pigment yellow 184 or different kinds, or also in the form of ready pigment dry dispersions, the TICOs or HycoFit LR. Next one. TICO, this is a very interesting concept where we are combining the properties of the inorganic and merging it with the organic pigments and creating a TICOs. TICOs stands for the titanium color, which is basically a mix of a nickel titanate and with a different kind of organic pigments. And this pigment is giving a very good color saturations, high gloss, and excellent processing characteristic. Because if one would like to go away from the lead pigments are giving a very high opacity. Very high opacity, and valuable organic pigments are protected by specially designed titanium yellow pigment that leads to the excellent light and weather fastness. Next one. This is our full range of the TICO range, mainly for the general industrial and powder coating application, can be used both for waterborne and solvent-borne binder system. Next one. I will really like to, friends, the time today allotted is not sufficient to really go through all these concepts, which really each concept is going to take more than 1 hour, and we are happy to come back to you if anyone is interested more details of individual side. This one is again the customized.
Surendraji, we have to take question answer. So if you can wind up within 1 or 2 minutes, we'll have to take question answer.
Yeah, can you go next one?
Yeah.
Only 2 minutes.
Yes, sir.
Okay, this is our range for the HycoFit, for the HycoSyn and HycoFit LR, which are the lead replacement. I can just go next one, only the last product range. Next one, next, because this is again the next one. Yeah, this is what I just want to touch upon. Heuberg is, apart from the color pigment, Heuberg is bringing the corrosion protection. And next one. And we have got a full anti-corrosive chemistry, basically from the zinc phosphate, modified orthophosphate, modified polyphosphate, organic inhibitors, and the flash rust inhibitor. So friends, I think I would like to stop here because the time is running out and we lost some time in the technical glitch. But I'm very happy, and we are happy to touch upon if you need any other, if you would like to go in the details of any one of the product line, you can please contact us and connect with us.
Aditya, I think he is on unmute. Can you unmute him? Raghuramanji is unable to start. Aditya, can you start the question answer from participant, please?
Yes. Let me see if there are any questions.
Or and then you just unmute him.
Yeah.
If there is any question, please ask.
Just a minute. At the moment, we don't have any questions. So if Mr. Raghuraman has a question in the meantime.
Yeah, he's.
Yeah, I have a question here. So Surendra Gupta ji,
Yes.
whether Tico grades have same hiding as that of chrome pigments?
Yeah, it is actually it will depend upon the end application and which kind of binder, but it is very close. And people are already using the Tico products for the replacement of lead chromate in the high-end application.
Okay.
There is another question. Surendra, I have one question regarding this. Now the awareness of the compliance. Now the REACH and EN71 and ACMI, they are all talking about the hazardness of the pigment. So what about the heavy metals and the, the pentas or the soluble copper? How the compliance report and when we started the awareness in India, how the pigment compliance to the standards?
Okay, if I address this question from the Heuberg perspective, since we provide our most of the product to the European, Japanese, and the North American markets. All the pigments are complying to different regulatory regulations. In terms of the Indian perspective, I would like to mention that all the global regulatory compliances are basically originating from the very similar kind of fundamentals like heavy metals, other kind of, and then the differences from the one country to another country is coming based on the testing methods. So organic pigments, we need to see which pigments are we catering. But if you have got any specific product, then we are happy to really provide you more details on this aspect.
Sure, sir. We'll ask the offline some of the pigment and then requirement.
Yeah. The question.
In fact, just to add on here, I would, I think this will be going to a very good topic if you can take up in the next Color Society seminar about the regulatory compliances, because this is going to be the future.
Yes, sir. This is a very big topic. We'll discuss. Aditya ji, if there is any question from the participant, you ask. Otherwise, I think we'll end the session.
I have got a question, please.
Pradhan ji, please ask. Let the other participant ask from this, Pradhan ji. We have already time slot. We are already late. So, Aditya, yeah.
Let me try just for Raghuraman ji, can you just say something? Let's see if we can hear you. No, I think your voice is not.
Can you just start it and yeah, please. Aditya, time is
okay, Raghuraman ji, that we will take the next technical session. Is that okay?
Yeah.
Yeah. Thank you. I think the audio says some input is issue. So I'll move on to the next session. Thank you, Surendra ji, for your session. Without much delay, I'd like to move on to the next session, which is we have our next speaker waiting, Miss Alison Musto. So Miss Alison is the Technical Service Manager Europe for in the Paint and Coatings Additives Division for Borchy America. And she also has been previously with PPG Industries and worked on various projects, including collaborations with large automotive customers such as GM and Chrysler to develop new and innovative products, and a professional development coordinator and the board member of PPG's Young Professional Organization at the Cleveland chapter. And she's also, Six Sigma Green Belt holder. So with this, I'd like to invite Miss Alison Musto for her session today on high performance dryers for oxidatively curing coating.
Okay, thank you. Thank you so much for having me. Can you hear my audio okay?
Yes.
Okay.
Yes. I do not see where I can share my screen.
You will get that now.
Okay.
Yes.
There it is. Okay. So can you see my title slide?
Yes.
Okay, great. So thank you all for joining me today and for joining this webinar. I'd also like to say thank you for inviting me to speak. Today, I will be discussing, oops, can you still see my screen?
Yes, I can see.
So today I will be discussing Borcher's high performance catalyst for oxidatively curing coatings. Before I get into the presentation, the overall theme of this Color Society webinar is the impact of COVID-19 on the paint industry. So I wanted to touch on that quickly, as this presentation is focused more on technology and the new performance benefits brought by Borcher's high performance catalyst. So what we see as an impact on the coatings industry with COVID-19 is specifically related to these oxidatively curing coatings. So mainly that is your Alkyd resins. Alkyd resins can be used in many different industries, but of course one of the major industries that they are used is in decorative and architectural coatings. And what we've seen throughout COVID-19, everyone's working from home more people at home have time and are really looking to renovate and repaint their house. And we really see a boost in this decorative coating market and a much higher demand for these Alkyd resin systems. So we've heard a lot of different things, a lot of positive impacts, a lot of negative impacts. Of course, the negative impacts are probably greater, but at least in these decorative coatings and Alkyd markets, we're seeing some growth, as well as some other aspects that I will touch on in this presentation, and many other people have touched on in moving forward with these Alkyd resin technologies and these architectural paints to be more biorenewable and less toxic. So I just wanted to briefly touch on an impact on COVID-19 in reference to this presentation, but the main focus on this presentation is showing the performance benefits of Borcher's high performance catalysts. So to give a brief agenda, and I just want to make sure that the presentation is working properly. Can you see the agenda slide?
Sorry to interrupt you, Alison. You are not on the full screen mode. So if you can go to the reader mode, we can see your presentation in the PPT. Yeah, now it's fine.
Okay, good. Okay, I can't see it myself, so yeah, please interrupt if there's any further technical issues. Okay, so the agenda for today's presentation is I'm going to talk about the current state for Alkyd resins and dryers. I touched on that a little bit in the previous slide. I also want to talk about why is the industry reformulating these Alkyd resins, and that's where Borcher's high performance catalysts come into play. I'll give an introduction to these high performance catalysts, and I really want to focus on the performance benefits and advantages of these two product lines we have. One is an existing product line that I'll be sharing more information on, and one is a newly launched product line that the Color Society is actually one of the first presentations I'm giving that includes this new product that we recently launched, which is our Borchy Dragon technology. And then at the end, I'll leave time for questions, of course. So the main focus of this presentation is on Alkyd resins. So to go back to the basics, since this is a very broad audience, I always like to include more background information. So an Alkyd resin is a common name for an oil modified polyester resin. These resins are used, as I mentioned before, in architectural, do-it-yourself marketplaces, light industrial, wood care. Wood coating is a really large one for these Alkyd resins and drying oils, as well as printing inks and some automotive aftermarket coatings. So what do we see as the advantages for these alkyds? For a long time, alkyds were being formulated out in the industry and replaced by different technologies, especially in waterborne like acrylics. And there are waterborne alkyd technologies like emulsions, but we're seeing a big increase in demand for these alkyd resins because of the aspect of biorenewable. I'm gonna put on my laser pointer. So alkyds can be derived from many biorenewable oils. And in previous presentations, many people have discussed that our customers, the consumers, are demanding to have these bio-containing products. So with this biorenewable, that also goes to leading towards being non-toxic, being metal-free, and so on. So this is a big advantage for alkyds over other chemistries, is they are bio-based. They're also inexpensive. They have a very long and stable shelf life, which is great for your architectural and decorative marketplaces. And they provide certain properties that are important for many paint systems, like hard films, and as well as stain blocking and other performance benefits. Many of those will be covered in this presentation. So why do we need dryers with these alkyd resins? So alkyds dry via auto-oxidation. If unaided, the reaction is very, very slow. So dryers are needed to act as a catalyst. So these are our high-performance catalysts. So they, in these dryers, in the dryer package that is utilized in these alkyd resins, greatly impact the performance and the dry time, as well as many other properties in your paint, like blocking, stain resistance, hardness, color, and other performance attributes. So it's very, very important that with these alkyd resins that you have the correct dryer package. So I wanted to touch on what do I mean by a dryer package. So the standard dryer package for many systems are a cobalt carboxylate, zirconium carboxylate, and then a calcium carboxylate. And they have different functions in the curing mechanism when it comes to alkyd coatings. So cobalt is what creates the oxidation reaction, and that happens on the surface where the oxygen is absorbed into the alkyd resin and film. So here's your substrate, and the red square is your film. So cobalt brings you oxidation on the surface, but not all the times can it bring you complete curing and oxidation through your entire through to the substrate. So you do need to utilize through dryers like zirconium. And zirconium carboxylates cross-link. They cross-link hydroxyl and carboxyl functionalities on these alkyd resins. So you get your surface and your through dry utilizing two different dryer technologies. You have to balance these dryers in order to get the right oxygen absorption in through drying, as well as the correct water for waterborne emulsion or solvent for solvent-borne coatings to evaporate out of the system. So you have to balance. Really, the balance of your formula is very, very important, so that if you don't have enough solvent evaporating, then you can have wrinkling, trapped solvent in your film, which leads to tackiness, wrinkling, and poor hardness development. So like I mentioned before, the most common dryer package is this cobalt, zirconium, and calcium with your surface oxidative dryer, your through dryer zirconium for coordination and cross-linking, and then you have your auxiliary dryers, which is more for pigment wetting and helps with loss of dry, for example. What I'm going to speak on today in Borcher's high-performance dryers is our Borchy Oxycode and our Borchy Dragon technology. And these actually cure in a different function, which can allow for both oxidation and coordination. So you can utilize one product for surface and through drying, depending on your alkyd type. So this is, we have something to offer for, again, I've mentioned waterborne emulsions, water reducible solvent-borne alkyds. I know solvent-borne is much more important in the Indian marketplace. So we offer for all short, medium, long oils, a different high performance catalyst to cover all solvent-based, all solvents used for these alkyd systems. I'm going to touch on, and this is the slide where I go on over why is reformulation happening with these alkyd resins right now. And this main driver is really coming from the United States and from Europe, where Tosca and REACH have reclassified cobalt metal as well as 5 cobalt salts to be restricted in use into coatings. This is going to have a very big impact on the decorative DIY market, since the end consumer cannot have these cobalt salts and cobalt metal in their paint formulation. There's been some time, you see this timeline. It's a very complicated slide. I'm not going to go over each point. Very complex issue, but it's an overall regulatory trend that globally in the European and American markets, cobalt is being reformulated out of these systems. And for me, I believe that this is going to continue on in adjacent markets like India, Asia, South America, that eventually the cobalt will be completely removed. So as one region starts to reformulate out, many of the regions follow. So this is the main motivation, I should say, for cobalt replacement and replacing these cobalt catalysts and alkyd formulas. But I don't want this to be the focus. So what the focus is not that these Borchy Oxycode and Borchy Dragon technologies are cobalt replacement. They do remove that troubling regulatory aspect in your paint, but they also bring significant better performance in your overall formulation, bringing you higher paint quality. So this is what I'm going to focus on now. So I would like to introduce our Borchy Oxycode and Borchy Dragon technology. These for Borchy Oxycode has been on the market for a few years. This is our unique patented organometallic ligand technology. We also have just introduced our Borchy Dragon technology. It is also a accelerated ligand technology of a different metal type. So for solvent-borne, we offer both the Borchy Oxycode and the Borchy Dragon for all applications. The benefits, which I'm going to go over in detail one by one, include, of course, cobalt-free. That's very important. Another important part to mention is with many carboxylate acids used in carboxylate dryers now are containing CMR toxicity, so carcinogenic, mutagenic, and reproductive toxicities, which Borchy Oxycode, by eliminating the need of these through dryers and dependency on so many carboxylate metals, can also help in your regulatory stance of your coating to just make it non-toxic with cobalt-free and CMR-free. It dries clear. The Borchy Oxycode brings you brighter whites. Borchy Dragon as well has less yellowing compared to cobalt technologies. We have excellent performance in adverse conditions. This is definitely something I'm going to touch on in more detail, as I think that's very important, especially for the Indian market, that as a country being so big, you have so many different temperatures and humidities throughout your entire country. So it's very important to have the same performance under these adverse conditions. So different temperature, different humidity. The other benefits include reducing loss of dry or eliminating loss of dry, and also non-wrinkling performance in thick film applications. So of course I'm going to go into more details on each of these benefits, but I'd like to introduce to you what products that we have in our product portfolio of these high performance catalysts for alkyd resins. For waterborne, we do offer Borchy Oxycode 1101, which is in water. This is very important for your waterborne alkyd emulsions. Also can be utilized in your water reducible alkyds. You have your Borchy Oxycode, which is in propylene glycol for solvent-borne systems. And then we also offer 1310, Borchy Oxycode 1310, which is utilized in solvent-borne systems that have thixotropic resins that might be impacted by propylene glycol. It's not affecting the dry time, but it could be affecting the rheology of your system with these thixotropic resins. So 1310 has been developed to remove the impact. We also have our Borchy Dragon. So this is our introduction to Borchy Dragon. This is specifically designed for high solids and long oil alkyds for low VOC coatings. So this is something, a market trend that we see going on with alkyd coatings, is to remove the VOC. So increase your solids as much as you can, reduction in VOC and solvent porn to be more compliant and better to use. So Borchy Dragon, has been formulated specifically for these high solids, long oil alkyds. Borchy Oxycode and solvent-borne. So we have multiple offers for solvent-borne systems. So Borchy Oxycode's the focus for your short oil, medium oil, and Dragon can be utilized in your long oils and high solids, as well as Borchy Oxycode in certain systems, but where we see performance benefits with Dragon is in the high solids and long oils. So Borchy Oxycode, I just wanted to quickly go over how to utilize these dryers in your paint systems, as they are not a one-to-one replacement for cobalt. So Borchy Oxycode and Dragon are utilized in your paint system the same way. They are utilized based on resin solids as supplied. So many carboxylates you calculate based on the present metal, if you have 6% cobalt, 10% cobalt, and so on. The Borchy Oxycode and Dragon are utilized as supplied, calculated on resin solids. This is not a direct one-to-one replacement for cobalt. It is utilized on a ladder study. So we test from 0.5 to 2% on resin solids. This is because you can see changes in your performance based on overdosing these dryers in your system. So here we have an example that 1%, 2%, and 3% Borchy Oxycode was tested on resin solids. And if you would have started at 1%, you might not have met the dry time needed if your goal was 3 hours in the short oil. So testing at 2%, you received a faster dry time and met your goal, but we don't have the linear slope of adding more catalyst gives you faster dry time. Actually, by overdosing, you have the risk of negatively affecting your dry time. It's a very different mechanism with these dryers. So what we offer here is we say do a ladder study. But we also offer, as technical service manager, I should say, we offer a lot of technical support. We have technical service locations in United States, in Shanghai, as well as in Europe, which I manage. So we can offer you this reformulation support and guidance when looking at the Borchy Dragon or Borchy Oxycode in your formulations. So now I would like to focus on the performance benefits. So I quickly went over many of the performance benefits. So now I'm going to go into detail one by one of these benefits. A major issue with alkyd coatings in globally is that they are greatly affected by temperature and humidity. So if you have a change in humidity anywhere between that's above or below the standard 40 to 50%, or you have a change in temperature that is above and below standard scientific room temperature of 20 to 22 C, then you can have significant impacts in your drying time. So currently, the temperature in Europe today is significantly above average of almost 40 C. I'm here in Düsseldorf, Germany, so anyone trying to paint and stain any wood coatings outside would have a significant reduction in their dry time because of this high temperature, so these adverse conditions. And globally, you rarely see an area that's actually in the standard temperature. So it's really important to have a robust dryer package, a robust dryer that can be formulated at these changing conditions. So some of how paint can be affected by adverse conditions. If you're painting when it's too hot, like today in Germany, your paint can dry too rapidly, which can compromise adhesion to the surface. If the temperatures, I'm sorry, this is in Fahrenheit, if the temperatures are above 90 degrees Fahrenheit, so we'll say around 40 degrees Celsius, it can cause blistering, peeling, bubbles. Any temperatures below 55 degrees Fahrenheit can cause dry times to be extended, taking over 48 hours to cure. At low temperatures, alkyd paints can also become too viscous, making it too difficult to apply the paint smoothly. So, how does Borchy Oxycode then work under these high performance catalysts? Hello? Hi, is there an issue?
Aditya, can you mute?
His audio was on by mistake. Please go on.
Yeah.
Okay.
Aditya.
Okay. Hi. So, where was I at? So I'm talking about adverse conditions. So this graph is looking at dry times in hours, as well as we're comparing 3 different conditions. So your standard 25 degrees Celsius, 50% relative humidity, your hot conditions at 37 degrees Celsius, and low relative humidity, and cold temperatures being the blue at 2 degrees Celsius and 40% relative humidity. With this Borcher's high performance dryer technology, this accelerated ligand technology, you can see that you get low and stable dry time across all of these different conditions, these weathering conditions. So this allows your formulations not to be so seasonal and not to be so regional. So you can have the ability to have more globalized formulations, as well as your customers have an extended application window for these alkyd coatings, which is really important. For us, we want our customers to be painting more and longer, leads to more business, of course. So this is with our Borchy Dragon technology. Again, under adverse conditions, this is our standard lab adverse conditions. We test at cold temperature, very high humidity, so at 10 degrees Celsius and 80% humidity. And with the Borchy Dragon technology compared to competitive cobalt-free, as well as a cobalt carboxylate control, you see that you have very similar dry time, so a lowered impact on that adverse condition curing. One of the biggest advantages of these high performance catalysts is in the color performance. So Borchy Oxycode cures completely clear. Many carboxylates are very dark, many competitive cobalt replacements are very dark in color, so it has this direct impact in yellowing just by adding the additive or the catalyst into your white or clear coat. Borchy Oxycode cures completely clear, so it has 0 impact on color. What you can see here is this is how we read our dry times. We can read on any surface substrate. It's a circular recorder. So not only do you see improved color performance in this waterborne medium oil alkyd, you also see faster dry time. This is with our Borchy Dragon technology. This is in a solvent-borne high solid system. And the results, again, with the Borchy Dragon, though it doesn't cure completely clear like the Borchy Oxycode does because it's a different technology, it has been formulated to significantly reduce the yellowing and improve the color performance and whiteness of your alkyd-based coatings. So in these solvent-borne systems, this is really important to many of our customers. It also inhibits, and this is the next slide, it inhibits the yellowing of alkyds over time. So cobalt carboxylates always repropagate. Can you please mute your mic? Thank you. So cobalt carboxylate dryers are constantly repropagating and creating free radicals, which is causing yellowing over time. So when you have a cobalt dryer in a dark area, UV sunlight usually inhibits this. But if you have, for decorative coatings, you have a room that doesn't get very much sunlight, you'll see over time with your cobalt dryer, it gets yellower, yellower, yellower in this alkyd coating. Borchy Oxycode does not have yellowing over time, so you can have a very stable, bright white coating. This was a topic that I touched on earlier, is the lessons dependency, so lower dependency on through dryers. This was a system that we had brought into technical service that includes, I think, almost every carboxylate dryer in the book to be able to cure this solvent-borne long oil high solid system. So very difficult to cure system. It's included manganese and cobalt. This is this is what we see with many customers trying to reduce your level of cobalt by adding carboxylate manganese in the system, but that really has a huge impact on your yellowing of the system. And of course, manganese carboxylate does not have the same curing efficiency and speeds as cobalt, and not as fast, of course, as our Borchy Oxycode or Borchy Dragon technology, which brings a faster curing time. So they had manganese, cobalt, zirconium, zinc, also an accelerator or like a chelating agent, as well as calcium. And in this case, we were able to remove all of these carboxylates out of the system and find equal curing time with just our Borchy Oxycode, and both containing an anti-skinning agent. That is another conversation, which I could have another 1 hour presentation on the status of MECO, but Borchy's does also offer MECO-free and MECO replacements for anti-skin. Another thing to note is commonly on resin solids, so this is the addition rate as supplied on resin solids, but many times the standard cobalt level is around 0.06% cobalt metal in your alkyd paint. With Borchy Oxycode, it is used as supplied, but it has a very, very low activity rate of the metal ligand technology. So taking into account that ligand and then even lower amount of actual iron metal, you're only adding at a 1% addition rate. It's a very, very low amount of metal into your coating. So that is really great for looking at the toxicity of your paints and coatings and the regulatory stance. Another point I talked on is no loss of dry over stability. So what we do, and the gray is the initial dry time. So we took the paint and we threw it down, recorded the dry time. And the red is after 60 days stability at 50 degrees Celsius. So the wet paint was in an oven for 60 days. We reapplied it and measured the cure time. This really correlates to a few years of this paint being on the shelf. So how does your dry time change over stability? You see with our Borchy Oxycode, our high performance catalyst technology, that we have a very stable dry time over this stability. So a very small delta change, whereas the cobalt has a much higher change in dry time. So that is loss of dry. This is a benefit that Borchy Oxycode and the Dragon can bring to your paint and coating system, is longer shelf life, better stability. The next slide, I'm going to show a video of a time lapse that we made of a thick film coating with the Borchy Oxycode on a wood panel. So I'm going to let you watch the video, and then afterwards I will discuss.
Hello, this is Mr. Very nice presentation. We are very happy to hear all this your speech. I would like to one question for you. What about the water-based dryer can work in the system?
I have a few more slides, only about
Can you hear?
2 more. Yes, I can hear you. I have about two more slides to go through, and then I'm going to open up for questions.
She will conclude, then you will ask. She has some few more slides. 2, 3. Yeah. Please carry on. Please go ahead. Please.
Okay. I'm sorry if the video was a little loud, but I think it's a really great visual tool. So I'm just going to start this again. Hold on. There we go.
Sorry. Yes, please go on. You can continue, please.
So here you should be able to see with the cobalt carboxylate, you have wrinkling. This is a time-lapse video. Okay, I'm not sure if the music came through on that. It's always interesting when you do this over a webinar. But this was a short time-lapse video where we had 2 panels. You can see here the cobalt carboxylate standard formula and a solvent-borne wood stain with cobalt and zirconium. And on the right side, we had a Borchy Oxycode paint system applied at a very, very thick film. So we can say probably around 400 microns. So very thick film. One thing to note is these wood panels are bowed, so you have a pooling effect of your coating. So you have even thicker film on the edges and thinner film in the middle. One common problem with cobalt carboxylates is this wrinkling effect with these high film builds. That comes from the fact that it is a quick surface dryer. So if you have too thick of a film and it cures on the surface, you have a lot of entrapped solvent causing wrinkling underneath your coating, as well as softness, poor stain resistance, lower hardness, a lot of issues in your coating. So Borchy Oxycode is very resistant to that because it's both a surface and a through cross-linking dryer. This brings you improved performance. I think here you can clearly see the difference in the color performance. So you're getting more of the wood grain, you're getting lower yellowing tendency, no wrinkling, as well as your customers in formulas like decorative coatings where you have a lot of non-professional painters. You don't have to worry so much about defects because of maybe the pooling or poor application. So this is a big benefit with both the Borchy Oxycode, and we have a time-lapse video of this coming out with our Borchy Dragon soon. Hopefully you will see it on our LinkedIn page. The last comment I had in with the Borchy Oxycode in the more short and medium oils, and sometimes in long oils as well, we see the reduction or elimination of use of anti-skinning agents. So this is a really big benefit as well. So what we look at when we're evaluating Borchy Oxycode in Dragon is to see if we can replace your formula of cobalt, zirconium, calcium, and mico with just Borchy Oxycode or with just Borchy Dragon. So bringing you the performance benefits of 4 products, 4 dryers with 1 new high performance technology. So this is my final slide. I think I went over in time a little bit. I apologize for that. And what I wanted to mention as a whole is this is not a focus on cobalt replacement, though cobalt replacement is the motivation to change and utilize these dryer technologies. What we see is an improvement in the performance of your coating. So this can be for decorative coatings, industrial coatings, any direct to metal coatings using these Alkyd Resin technologies or any oxidatively curing technology. These benefits include in formulation simplification, so minimum dependency on through dryers, elimination of potential use of anti-skinning agents, faster drying times, which is a benefit for all industries. For the decorative markets and for more non-professional coatings, you see excellent performance in high film build in removing wrinkling. Across all industries, you see excellent performance in adverse conditions and stability over loss of dry. And one thing I didn't touch on, but for direct metals coatings, we see improved adhesion as well. That correlates to better corrosion. So typically in this presentation, I'm showing you all the benefits which can be applied to different industries, but we also have very specific presentations for each different industries that's utilizing these resins and the benefits that can bring to them. So I would like to thank you very much for your time and your attention and patience through this presentation. And I hope you see the many benefits in bringing a higher performance coating with Borcher's high performance dryers.
Thank you, Alison. Hitin bhai, just we have a limited that 1 or 2 minutes. I request Aditya can take 1 or 2 questions from participant. Aditya, is there any questions? Otherwise, we are yeah.
I think Hitenji had one question, right?
Yes.
Hitenji, please.
Oh, it's okay. From the audience, they can ask the questions if they want.
Okay, so
anybody?
There are 2 questions which have come. 2 questions are there. Should I go ahead with them?
Yeah. Hiten bhai, you can go ahead with this. Your question. You can go ahead with your question.
I had Mrs. Musto, I would like to ask you, what about the water-based system works in the dryers?
Yes, so we do offer a product for waterborne into our Borchy Oxycode 1101, and that can be used in all waterborne emulsions. It is supplied in water, so you don't have to worry about with many like cobalt carboxylates having hydrolysis issues in these waterborne coatings. It's fully stable and has excellent performance in water.
Right.
Aditya ji, if there is no any question for participant, if there is a questions, we'll forward it to Mrs. Alison for the answers and all. So we'll end the session over here and we'll start.
Yeah, so there are a couple of questions from the audience. So there's a question from Milind Mahajan, which is what's the cost increase involved from conventional dryers to your variety, the Borchy variety?
So there's not, I can't say that there's a formulation that I can provide to you to say, based on your current dryer package with Borchy, Oxycode, or Dragon, that you would be utilizing this level and it would be this cost. It's so dependent on the formulation and what can we do overall. So are we able to take a standard cobalt, zirconium, calcium, MECO system and reduce that to just Borchy Oxycode? And then what are the dosage levels? Very dependent on the oil types, the oil length. Is it solvent-borne? Is it waterborne? So yeah, that's a very complex question to answer. I think you can contact our Borcher's representatives in Mumbai and have this conversation, as well as if you are interested in requesting a sample and doing any testing, technical service can offer you support in how to formulate.
Yeah, so there's one more question which I'd like to take, and then we can move on to the next technical session from Mr. Samarjit Sate, and he's asking is cobalt the only culprit for yellowing, or are there any other contributory factors for yellowing?
So there are many contributing factors to yellowing. Manganese carboxylates are very, very common to cause yellowing in coatings, in Alkyd coatings. Also, different secondary dryers can cause yellowing. Some very difficult to cure and difficult to get your proper hardness. And some regions still utilize aluminum. This has a greatly high impact on yellowing in the coating. So it really depends on the package, the dosage as well. But those are mainly the carboxylate technologies. These high performance catalysts from Borcher's have decreased or eliminated the yellowing in these coatings.
Okay, thanks, Alison, for your presentation. And with this, we'd like to move on to the next technical session. We have Mukundra Hulyalkar ji from Paint Tech Consultants. Mukundrao ji is the director at Paint Tech Consultants, Mumbai Paint Technology. he's a paint technologist based in Mumbai. He's the honorary editor of Paint India. He's also popularly known as the Flying Consultant, and has consulted more than 500 units in India and offers consultancy to many foreign countries. He's also the recipient of the Udyog Shri Award in '97 from Maharashtra government, ISPA Mitra Award 2012. And I think what even Mukunji has mentioned on his advertisement, the generation and the technology change, but Mukunji remains the same. So with this, I'd like to invite Mukunji for his technical session.
Yes.
Mukunji, we can
Aditya,
see you.
can I start?
Yes, we'll play your presentation. Just give us a couple of minutes.
Yeah. You put a first slide only.
Yes. Yeah, the same one, water, Abhishek. Abhishek, can you play the presentation? Yeah, perfect. Just stay on this. Mukunji, we have shared now.
Yeah.
You can see on the screen.
Okay.
Yeah.
Yes, I'm saying. Okay. Thank you very much for a kind introduction and a short introduction. And I'm very happy because the time is very short. So now, first of all, if you can call our President Color Society, on the dais. I want to give him a compliments. Is it possible? I want to give him a feather bouquet.
Yes, Mukundra.
Yes, thank you very much. Under your leadership, our entire team has done a very successful program. And today is the last day, and I am a last speaker, I hope. So I want to give this. This is in your president tenure. This is a feather in your cap. I will show you this the bouquet made from feather. And being a technician, you will all find I can change the color also.
Oh,
so, thank you very much.
All the team. Thank you very
now
much.
You know that that technicians are magicians also. Now only thing, President sir, you have kept a time slot of 35 minutes, which usually we are not habituated. In our school days, we used to have 45 minutes period. So now we remember all our school days. Today, my presentation will be little fun, little knowledge, and I will be doing a sort of a partly replacement to the motivational speaker also. Okay. So there is, now I will start my lecture. Now we will remember our school days. The school days, our period used to start with the bell, the brass bell. So now we start our classroom. Just 3 lines I will read before I start my presentation. Erase error with forgiveness, dip brush with patience, and color this event with love towards color society. These are the 3 lines. Just now I written, and now usually I'm not comfortable with the laptop. I am more comfortable with the lip talk lectures, but today I'm giving on laptop. Now this subject is something controversial subject for a technical people, and for I will say orthodox technologists will not like this subject. And this is controversial subject, and mainly there is a suspense in the title. The title is not clear. Many people told me the title is not clear. What is meaning of, what is the subject? So water, now I will put to the audience. You can tell me how you want. A la carte lecture also I can give. Whatever you want, I will speak about water. But water addition in enamel, with water addition in enamel nowadays we are doing from last 20 years in India. I don't know about other countries. And for this, a lot of secrecy is maintained. I don't know why we should be having that, the guilty feeling that adding water to the solvent-based paint and all. Now, I will go to my lecture. This water is called in Indian language, Talni, Niru, Vellam, Pani, Pani. Low they call in French. Water addition enamel I have started in 1980. Just this idea struck to me, a revolutionary idea. One painter came to my home in 1980 for painting my house, and in enamel paint 1 liter, he added 10 ml of H2O, 10 ml of the water. And it was a learning from me, learning for me. I asked, why you are adding water to enamel? It is a totally criminal. So he told, sir, ये थोड़ा पानी डालेगा ना तो ब्रशिंग अच्छा आता है. This is the idea invented by an illiterate painter, which I took forward. In 1990, I have developed many products. I started 1990 onwards. Then I was criticized like anything. But now even the multinational have the water additive, and they call it a green paint, eco-friendly paint and all. So this, as I told you, a very controversial subject. I will put my views in this and my experience of 31 years on R&D on this. I will share in 31 minutes. One more, for session chairman, when I am coming short of time, you just remind me 5 minutes before, and you make a signal like this. Like this, you make a signal, then I will cool down, stage will start, and within 5 minutes, I will close the session. Okay. Now, next slide. Next, please, Aditya. Now, as I told you, the name water. So, if I tell you sunny, what will be the suffix? So, the sunny, many sunnies are there. The first sunny I will show you. Can you tell me who is he? Celebrity from audience, somebody can tell me whose photograph is this?
Sunny Deol.
Sunny Deol. Who told?
Salunke.
Salunke sir, you deserve one chocolate from me. I will send you by courier to you. Okay, physically I cannot give you now, like our physical seminar, but thank you for helping me. Now, one more experience I will share. Once I had been to Fasta, one of my customers, I'll give you some live story. In these rainy days only, I have shouted on one skilled worker that, "Arey बारिश आ रहा है, पानी अंदर उड़ रहा है. You are not taking care." And I have shouted and I have given a big lecture and the firing. After 10 years, I went with my water additive to him. Then he asked me, "Sir, आप पानी के थोड़े ड्रॉप्स उड़ रहे थे तो आप इतना चिल्ला रहे हो और अभी आप 100 लीटर पेंट में 10-10 लीटर 30-30 लीटर पानी डाल रहे हो." So this is the story. Then because as technology changes, our mindset changes. And I will tell you, for knowledge and technology also, there is an expiry date, like our medicines. Usually, President sir, I don't give any sponsor lectures. Usually we consultants are charged for the lecture. And here we are giving money to promote our products. But even though it is a sponsored lecture, I will not promote any my specialized product on this platform. But Dukandari karega nahi. I will tell some of my experience and technical aspects. For that one, you can contact me on my personal number, landline and mobile. Here I will give you my personal experience R&D. Usually now water additives available in market, they are class 1 is emulsifier class, 9.5 mole ethylene oxide condensate and so on and so forth. Many emulsifying agents made from acid slurry neutralizing and so many. Then caustic soda based some additives are there. Casein as a buffer, and as a buffer some people use sodium carbonate, sodium bisulfate, etc. Quaternary ammonium compounds are also used as a water additive. Polysaccharide resins are also available in India, imported one. And many people intelligently use, salute to them, they use polysaccharide based thickeners which we are using for water based paints as a water additives for enamel paints. Certain bentonite clays are also can hold. The basic theory is bentonite clay is miscible with water also, solvent also. So it will hold water and solvent together. Next slide, please. Can anybody tell from audience name of this celebrity? Can anybody tell name of this?
Sunil Gavaskar. Sunil Gavaskar.
Still that chocolates are there. Chocolate stock is there. Don't worry. I will send you chocolate by courier. You send your address to me.
Yeah.
Then one additive, I will not take the trade name, but it has become like Bisleri, very popular name in our paint industry. HAM, Hydro Additive Mukund. This additive I have developed in 1990, and many developments are still going on. This is my very favorite hobby come subject. Hydro Additive Mukund. It is not emulsifying agent. Using emulsifying agent for water addition, I will call them the chemist who is having very limited knowledge, and he is still in junior KG class. In additive which I have developed, my thinking, I will give the thought process. If you take 100 liter paint, if your viscosity is 100 seconds, when you add my additive and add water, suppose if you want to add water 20 liter, 10 liter water you add, viscosity will drop to 80 seconds, which is very important. Your water addition should be as a solvent addition. It should cut the viscosity. Water should react like a solvent. This basic funda you keep in mind. And again, if you add remaining quantity of 50% water, again the viscosity will come to original 100 seconds. That means the paint is telling now my thirst is over. Don't add more H2O to the batch. Now, how to determine whether your paint is emulsified or not? In Sanskrit, we call praman. Iska praman kya hai? So increase in the viscosity. When you emulsify alkyd, your viscosity 100, it jumps to 180, 200 seconds. That means, according to my theory, you are a not good chemist. And then due to this, you lost a gloss. Gloss is lost, and increase in the drying time. Increase in the drying time. That I always tell in my humorous way, operation success, patient dead. The surgeon come out of the operation theater, he said, operation was very excellent. 2 kg tumor was removed from the stomach. But what happened? Patient dead. So if you lose the properties of the paint, drying, gloss, opacity, covering, hardness, stability, shelf life, then only water addition and water not separating for 1 year has no meaning according to me. Now, for any water additive, including me, there are some side effects. Like antibiotics, if you take one antibiotic, you have to take one vitamin tablet, B complex. Then you have to take one antacid, Paldi or something. Acidity will be there as a side effect of the painkiller or antibiotic. So there are some side effects. Now these side effects are usually many times you get, not always, viscosity drop is there after 2 months, 1 month shelf life. And paint 100-second viscosity with H2O will come to 50 seconds, 40 seconds. So for this, I have got one additive which is called, which is commercial name called green. This green, you have to add a fixed quantity of 50 ml, irrespective of the water quantity. Otherwise, water additives increase, additive dosage increases in geometrical progression, not in arithmetical progression, as per water percentage increases. Now, then another side effect is you get, when you add H2O to the water, in the hot sun, if you keep the panel, or the painting is done in hot sun, or painting is done in April, May, month of a very hot area in India like Delhi, Indore, the ambient room temperature is around 45 degrees centigrade. At that time, you get small blisters. Now, the small blister, the theory is simple. Surface dries very fast. As the substrate is also hot, surrounding medium is also hot, your MTO evaporates and the film dries. Cobalt dryer inhibitors, whatever you add, they will not work. And this is called popularly as solvent entrapment. Then MTO entrapped in the film will break the film and come out. Usually in our many solvent-based paints in oven bake, when there is no flash of time, at time of installing enamel roller coating also we get this problem. And we add zinc naphthalate as a retarder or cobalt to hold cobalt for some time, to keep your car in the first gear, not immediately drying. The zinc naphthalate helps a lot. Here, I have developed one additive called anti-blistering agent. This you have to add before addition of H2O in the batch, not after. Then one more hint which I learned, if your paint is based on chromes, now usually chromes are banned now everywhere, but in industrial paints in India, chromes are allowed. Lead is allowed even after permissible limit in industrial product, industrial primers, industrial enamels even. If the word industrial comes, then lead restrictions are not there. So in that case, chrome, you have to additive, if you want to add H2O, you have to increase additive by 50% more. Now, this is about long oil and rosinated alkyd and for medium oil alkyd base. And for CNSL, the CNSL water addition is very difficult in matte or glossy. CNSL based primers, glossy paint. For CNSLs, we are having a different additive called HACN. Next slide, please. Lastly, one more chocolate is available. Who will tell name of this celebrity lady? Very famous lady.
Sunny Leon.
Thank you. So, who don't know her? Everybody knows her. Now, basically, which I learned in last 30 years journey, alkyd making water soluble is not a challenge at all, not difficult. But solvent and water to make compatible, that is a challenge. And I will tell you my studies. I am giving you all my experiences, so you people take it further. Further, this R&D you can take further. Many technical people are there in the audience. Solvent plus water. This actually I found in polar solvent and non-polar solvent. On polarity of solvents, water addition is easy or difficult. Now, if water polarity and solvent polarity is same, they say in English we have a proverb, likes. So it is very easy. To mix water, even I have made one additive which can mix turpentine and water with a clear solution without increasing the viscosity and without seeing a separate layer for 2 months. So I am doing my R&D on that angle also. How to get water along with the solvent. They are pakka enemies. Abhi wo dono ko saath mein lane ka. Then that will be a great milestone for our entire coating industry. Now I had tried, it has helped me a lot. I have tried many water-based dyes. Just now also, I learned from her that water-based dyes are available. I tried from K-Tech. Dr. Srivastava has supplied me many dryers, and they have helped me a lot. Water-soluble dryers helps a lot for water addition paints. Even I can mix water and MTO, that I have told you already. Now, less MTO in the paint formulation, more water is easy. If you take high viscosity alkyds, high viscosity alkyds, then turpentine proportion will be less. But in paint, in 100 liter paint, 30 liter MTO we paint manufacturer has normally, and 30 is our resin manufacturer. So 100 liter paint around resin solids are hardly 35 to 40. So 60 is a solvent part. So less water is possible, 30-40%. I am calling 40% also less water. Less water. I want to go further. Now, if suppose water is less, solvent is less, you can add more H2O easily. Next slide. Next slide, please. This is an article from Chemical Weekly, and this is a special report how in the worldwide water-based industrial enamel consumption is increasing. Now, many people feel if you have a 100 liter paint at 30 liter MTO, the paint will be 130 liters, a great economy. But on this, the PVC ratio and other details are there. But in 30 minutes, we cannot cover all the aspects. But you are quite knowledgeable persons. This all I have taken care. And some people feel that covering drops. Up to 20 liter water addition, covering doesn't drop. So many of my friends, they take pigment for 100 liter proportionately and reduce alkyd and MTO, complete the paint at 85 liter only, and then add 30 water instead of 130. Here, first 15 liter water, they won't save money on pigmentation. Only resin MTO money is saved, and further 15 liter pigment money is also saved. Now, you will be surprised to know I am doing R&D on this for last 31 years from 1989. The more water, I have made one cement primer very successful, 1:1. Cement primer solvent based, normal cement primer solvent based, 100 liter primer, you can add 100 liter water successfully, and no dryers, because if you add dryers, they precipitate at such a high water concentration. I use intelligently zinc oxide little. So zinc oxide forms zinc soap with the alkyd, and the drying can be achieved. Now, next slide, please. Next, please, Aditya. Now I will tell you something what is happening all over the world. Actually, water reducible alkyds are available from many years. Long back, around 20 years before, I think, in India, Worley Chemicals was offering water reducible infinite tolerance alkyd. But due to the high price, at that time, water-based alkyd enamel costing was coming around 300 rupees per liter with the alkyd price and all. And our Indian acrylate enamel, I can say, first quality enamel, was costing RMC of 100 rupees. Now where 100 rupees and where 300 rupees? So therefore this product could not catch up, and India still, MPO use is not banned as the VOC and all. Now another alkyds are available in India. They are polysaccharide based alkyds. They are also used as a water additives. And on the plain alkyd also, I had tried to make the paints out of it. And very successfully, I could make the paint with good gloss and hardness and all. But only thing, the polysaccharide based alkyds is having less water resistance. Then I had done some work based on our knowledge of oil-borne distemper, our age-old. Stand oil used to be emulsified with casein as a buffer, and on that way I have emulsified alkyd also. That paint also I made, and I call that paint a totally agro-based paint. No synthetic things are added. Even you can avoid alkyd. Oil you can emulsified, no phthalic, no penta. Next slide, please. Now this is a just guideline formulation which I have made, and this was quite a successful product. Next slide, please. Next slide. Now in Indian market around 5 years before, this product came, premium semi-gloss enamel. This was made on high TG emulsion, total water-based only. But only thing, if you read carefully, I have underlined the words. Premium semi-gloss enamel water-based. This is suitable for wooden, metal and walls. That means metal means mainly iron, ferrous. Now there are challenges are there to coat ferrous with water-based paint. The challenges I will discuss in the next slide. Now this, in this world metal is there. Now you go to the primer of the same product was brought in the market, but semi-gloss in India, whatever you may say, still gloss craze is there. People don't like, except a few people on the decorative on the walls. They prefer to go for semi-gloss, but usually people want chaka-chak gloss. So the semi-gloss, this product could not catch that much mileage. So next slide, please. Next slide, please. Now this is a, for that enamel, glossy enamel, so-called semi-gloss enamel, this primer was available, but in primer, that metal word is lost. So I asked them what to do. They say you apply solvent-based primer only. We don't have primer which will have adhesion on the iron and the non-rusting and flash corrosion, long-term corrosion and substrate wetting, so many problems. So you have to coat solvent-based primer only and then coat with that semi-gloss enamel. And there is no, in this underline you can see, there is no steel or the metal bubble is there. Next slide, please. Now the water-based red oxide primers are also available. You will find very funny that water is a cause of corrosion, and here we call this primer as a anti-corrosive. These are the two controversial things. So now, and in this also, now recently, leading companies, 2-3 companies and our small scale also, with my help, we have bought gloss enamel also, not semi-gloss, full gloss enamel, but it is based on high TG emulsion. But it is having 3 major challenges. One challenge is there. One challenge is there. Adhesion. First is, one challenge is substrate wetting. If you take a panel, take water, you cannot spread panel due to surface tension, and you will get lotus effect. So to paint water-based paint, you require one substrate wetting agent. Then again, you require some adhesion promoter. because on iron, water-based system will not have adhesion. Some silence or something you have to take help. Substrate weighting you have to take help. And nail hardness and non-permeability also you have to take care. Then we use high TG emulsion. But again, the funniest story is this: if you take very high TG emulsion, TG about 51, 52, you have to go for 6 to 7% ethanol. That means you are going again back to the story, to the square one. It is as good as solvent-based paint only again. Again, the texture of VOC will come, or texanol is a trade name, but I can use the name coalizing agent. So, and then corrosion inhibitor, flash corrosion inhibitor, flash corrosion inhibitor and long-term corrosion inhibitor. Now, flash corrosion, we know after sandblasting, we paint immediately epoxy primer. Within a fraction of a second, corrosion starts. So, when water is there on the substrate for first 10 minutes, at that time, corrosion should not be there. Therefore, we take care of flash corrosion inhibitor and long-term. For all these additives, I have got one single solution. I developed one Alkyd emulsion. This Alkyd emulsion, earlier, I struggled with for 10 years to develop this product. When I was using styrene acrylic and pure acrylic normal emulsion, they used to gel after 2-3 months because of phthalic penta, what I know, don't know, but shelf life was less. Otherwise, product was okay. But now I have overcome that problem. I will get even hotbox stability also for 1 year, and hotbox stability for 3 days to 5 days to 7 days. Salt spray around 300 hours, 250 to 300 hours. This Alkyd emulsion I punch only 1 or 2 kilo in our regular water-based high TG emulsion. What happens? It takes care, being ultimately polyester, it will take adhesion problem is solved. Your substrate weighting problem is solved. So and breathability problem is solved. Breathability. So with this one solution, you can overcome many problems. And in fact, some of my friends are using this Alkyd emulsion, just punch in our regular water-based enamel, water-based paints, even right from distemper to exterior paint, high-end products also, to increase the scrub. Ultimately, Alkyd water resistance will be ultimate. Now, I will call this technology as a hybrid, water-based plus solvent-based. Now, I find after this all discussion, I find there is no Lakshman Rekha between water-based and solvent-based. Where the water-based ends and where the solvent-based start, we don't know, because now we are going to the hybrid systems also. Session Chairman, how much time is left now? How much time left?
2-3 minutes are there.
Okay, perfect. I will finish in time. I won't keep you
Go ahead,
in
go ahead.
difficulty and tension.
Okay, okay.
Next slide. Now last little fun we will do. Now technology is enough. Little technology and little fun in last is 2-3 minutes, and then I think I'm taking care of time limit. Now, why paint consultants are alive? All of us, not consultant, all of paint technologists are alive because metal corrodes. If corrosion is not there, it is our survival is very difficult. People don't need us. Wood decays, cement deteriorates. Therefore, we have developed so many plasticizers, cement additives, this and that. And plastic cracks after aging. So we have to develop so many plasticizers and all. And in our chemistry, I always say, I make some R&D and chemical, if it dries, it is a polymer we can use. If it is not, I can use that polymer as a adhesive. Now, I will tell you last summary, what I learned. These are very important. Like a radiologist, you see, he writes 2 pages, your kidney report and this report and that sonography report. Last 4 lines, he writes impression. So now I will give total my presentation gist of this water addition or water-based paints or hybrid paints or whatnot. Most controversial subject, most secrecy subject, nobody discusses openly. And everybody is enjoying water addition, but they are not openly discussing because they feel the guilty feel water addition is something wrong he is doing. But that thought is very wrong. Now, the impression is there for water addition, DCO alkyds are the best, not linseed. And high acid value alkyds get better response for H2O addition. For 10 liter H2O addition, in fact, I should not tell this as a additive manufacturer, water-based additive manufacturer. I am the first person in India to manufacture water-based additive. But I should not tell this, for 10 liter addition of water, no additive also is enough. If you want to add 10 liter water to enamel paint, add bindas. No additive required. Only you keep viscosity 70 seconds. After additive, it will go to 160 seconds. That you keep in mind. And water will not separate. Drying problem will not come. Anything, no problems, gloss and everything. Last point number 4. No hard water to be used. No hard water. And lastly, DM water the best. Demineralized water, if you use, then results are excellent. And 15% water also you can go without any additive. And even surprisingly here, with DM water, we don't get blisters without adding anti-blistering agent also in the hot sun. Last slide, please. Last slide, please. Yeah. May God bless you all. Take care of yourself in these days. This is what Amitabh was telling everybody in his program, very popular program. And I know the speaker should have 3 S. Stand up first for the speech, then speak, and then when to shut up. That is also important. So I will follow that after 1.5 minutes. I will shut up. Now, mainly, any questions, if you ask now on this platform, the answers will be free, of course, because after the session, I will be professional consultant. Then it will be charged. Now, last 3 lines.
Sir, I have one question.
Yes, sir. I will answer, sir. 2 minutes. Let me finish, sir.
Okay.
Last 2 sentences, sir. So otherwise, I will lose my link. I wrote 3 lines just now before this speech. Friends are like Asian paints. दुनिया बदल देंगे. Slogan is दुनिया बदल देंगे. उनका ad आता है ना. Slogan है दुनिया बदल देंगे. Girlfriends are like Everest masala. Everest masala का slogan you know क्या है? Everest masala का slogan. Taste the best. Taste the best. Wife, I am telling wife, not wife, sir. Not S, only wife. Wife is like mosquito coil. ढूंढ ढूंढ के मारेंगे. Slogan is ढूंढ ढूंढ के मारेंगे. And now I am, I think, complete in time. Session chairman, now over to you.
Sir, I have one question.
Yes, sir.
There is any additive for epoxy or PU?
Yes, for epoxy, to be very frank, the question is really good. For epoxy, water addition very simple. Because as I told you, solvents play very helping role. Diacetyl alcohol, all alcohol, spirits, alcohol family, the water is always welcome. And you know, in some age-old formulation we have in construction chemicals, epoxy products as a sealants and all, we have got water-based epoxies for waterproofing. So epoxy is very friendly with water. Even normal additives will work very well for epoxy. For polyurethane, I have not tried yet. For aromatic and aliphatic also, That I have not tried and I have not worked on that, but epoxy is very simple. I think age-old formulation, if I remember, we used to use oxalic acid and even vinegar also as a water additive.
Okay, Aditya, you can take it.
Yeah, there are a couple of questions from the audience. The one question from Kamini Baraukar is asking is mixing of water and solvent, is it water reducible system?
Yes. Once there's a good question. There at particular time when I was doing R&D, the stage comes when you can reduce that paint only with solvent only. The water addition is a last point. And some formulations I have developed some additives where water you can add to reduce the further paint thinning. That is also possible. Both are possible.
Okay, there's one more question from Professor VC Malche, and he's asking what is the after effect of the additive on the film performance?
Actually, sir, I discussed once in ICT some other questions regarding this product. What is my experience is this? My water additive in the film, water never remains. Even 0.1% water is not remaining in the film. That you have to ensure as an additive manufacturer. It is not emulsifying agent. Entire water should go away like solvent. If nothing is remaining in water, so water is coming, it is packed in the tin, it is used as a solvent, and it goes to the substrate, and entire water goes away. Then if water is not remaining in the paint and water is not affecting alkyd in any way, it is not reacting, it is totally neutral. It is coming from the paint manufacturer, packed in the tins, goes to the substrate, and water evaporates totally. If you can achieve that, then there will not be any performance problem on the film theoretically. And I have checked even salt sprays of such paints and primers also. Zinc phosphate primer I made around 30% H2 additive, 6% zinc phosphate, that passed 250 hours salt spray.
Okay, so I think there are some other questions, but I think we can send that to the committee and they can send it back to you so you can directly answer them. Or do we have time to take a couple of more questions?
You can take one or two questions if it is there, and
Okay.
one question.
There's one more question, which is sometimes there is a viscosity drop seen in water-based enamel. How to avoid it?
Yes. As I told you in my speech, usually this happens. Usually this is not with long-haul alkyds, rosinated alkyd. Usually what happens, rosinated alkyd are already over-polymerized, and it is possible due to the rosin in the formulation. Rosin is a peptidizing agent. Rosinated alkyd, your viscosity of 40% solid, normal rosinated, normal viscosity average is around 140 seconds. In long-haul alkyd, 50% solid viscosity is 100 seconds. Therefore, long-haul alkyds are not over-polymerized alkyds. So these alkyds, even without addition of water also, many times rosinated alkyd and rosin being peptidizing agent and being high viscosity alkyds taken above nearing to polymerization, gelation point we can go because there is rosin is present in the system. So these are already highly polymerized alkyds. So these alkyds have less storage stability. Now, the challenge is there with the water addition, this problem increases, exaggerates. So we have additive called green, as I told you, side effect. In fact, some of the paint dealers told me, sir, तुम्हारा पेंट तुमच्या पेंटचा खुळखुळा झाला. Because nowadays customer also very intelligent. They take the container on the shop. Sometimes they open, but before opening, they shake and they listen to the sound. If viscosity drop, then the customer says, are you supplying paint or it is solvent, thinner or the varnish? So this problem is there usually with halogenated alkyds. Without water also sometimes this problem is there, but you can solve it with, as I told you, side effect green additive. Thank you very much.
Yeah, thank you, Mukundji, for your presentation on water. And with this, we conclude the 3-day conference by Color Society. And we'd now like to invite Dr. Girish Nagarkar, Vice President, the Color Society, for the summing up and vote of thanks.
Hello. Hello.
Yeah.
Am I audible?
Yes, yes, yes.
You please, yeah, you are audible. Yeah.
Okay. Good evening, dear friends, industry colleagues, ladies and gentlemen. My very warm greetings to all of you and many thanks for your attending the 3-day-long webinar Technological Supply Chain Challenges in Coating Industry post COVID-19. Friends, the topic is very, very relevant to today's scenario, and hope we all got the insights from the valuable information shared by the speakers. We had excellent speakers all 3 days, and I believe everybody enjoyed the presentations. My duty is to sum up the seminar, but I am sure that you have got the relevant knowledge from our eminent speakers, and I need not repeat their contents. If anybody has any questions or additional information, they can directly contact us, or they can contact us through the website of the Color Society. Friends, Color Society has come a long way since last 68 years, and especially last 10 years had been phenomenal in making this institution really Atmanirbhar. And we had excellent programs, seminars, conferences, and there was tremendous response from the industry colleagues. This is due to your support and immense efforts from the industry colleagues and the managing committee. We were already discussing about the online diploma course in addition to our regular diploma course for so many months. But what has happened is COVID-19 has forced all of us to execute the actions rather than wait for more time. And I therefore urge all of you to take advantage of this course. And for more information, you can always contact us or visit our website. I also urge if you have not registered as a member, please register as the lifetime member or corporate members, and for that you can visit our website or talk to us directly. Now it is my duty to appreciate the support and encouragement provided by the industry and in making this event a success. And first of all, I would like to thank our event host, Asian Paints, and then co-host Jubilant Organics, KTech, NR Colors, Sohan Dichem, Pentec, Kansai Nerolac, Habak, and Lubrizol. I also thank all our technology partners. And last but not the least, all the participants who have attended the seminar, and their response is really overwhelming. Now I thank the convener of this webinar and honorary president, Mr. Manik Salunke, co-convener and joint secretary, Mr. Rohan Tavre, our honorary secretary, Professor Prakash Mahanavar, chairman of Pune chapter, Prasad Purandare, and chairman of Delhi region, Professor Harish Agarwal. And also all the committee members who have taken immense efforts to make this webinar a success. And many, many thanks to all the committee members. And I will not forget, thanking our past presidents for guiding us with very, very valuable inputs regarding the seminars. Once again, best wishes to all of you for the post-COVID situation, and stay safe and good night to everybody. Thank you very much.
Thank you all.
Thank you.
Thank you very much.
Thank you all. Thank you very much. Yes. Bye.
Yeah, thank you. Thank you.
Bye.
Bye-bye. Bye.